for everybody listening and for everybody tuning in. If you want to ask a question during a talk, the best way to do so is actually turn on your webcam, and that'll signal to us that you're kind of waiting. The raise hand feature in this interface is not very visible to us as moderators. So the best way to do that is flip on your webcam. That'll signal to us and to the speaker that somebody has a question. And then we can interact with questions that way. We'll also do questions after the talks as well. If your webcam isn't working or you can't use a webcam or you don't want to, you can ask a question in the chat as well, and we'll try to watch those as they go by and interrupt as needed. So as you may have noticed in Plumbers, there are two chats. So there's a chat associated here with the big blue button interface. That we're going to use as discussion for the current topic. So whatever the current presenter is discussing, we'll talk about that here. As the topics change and conversations want to continue, you will switch over to the Rocket chat, which is what I'm calling the hallway chat. So that's where we can just kind of continue conversations or go deeper on various topics. So I put a link at the beginning of this chat for that. I'll drop that in there again because I know there's a few more people here. So yeah, so we'll use the chat in the big blue button as kind of the discussion that's happening in the room, so to speak, and we'll use the Rocket chat as kind of the hallway chat. So yeah, so just flip on your webcam if you have a question or ask them in the chat, and we will try to get to them that way. Let's see, I think that's everything. Sasha, anything else we need to bring up?
No, I mostly just wanted to thank everyone for all the work done since last year. I think the testing and fuzzing community has advanced a lot in the past year, and I was hoping to thank everyone here present for their work, and hoping to see the same thing happen this year.
Yeah, it looks like there's a lot of familiar names in the room, so it's great to see everybody as well. So I think I set aside too much time for the intro. It looks like on the schedule we can get started early because I think we're going to have more
elaborate process, so it's not something that can be done by the fuzzer easily. But it also increased coverage in the other parts of Bluetooth stack because we now have this working device. And in just less than a month, we got 40 different bugs in Bluetooth stack. Some of them are quite concerning. And I think we're not done because we still covered just some initial part of Bluetooth stack. And the second subsystem is IO ring. We had some descriptions for IO ring and found some bugs, but we were not able to actually submit IO operations using IO ring, which is like its main functionality. Because it's quite tricky, you need to map file descriptor using specific size and specific offset, and then do writes to the shared memory at very specific offsets, which depend on the size of the rings and so on. So it's not like a typical system call interface. And to test it, we used syscaller feature that's called pseudo system calls. It's a feature that allows to encapsulate some logic using just procedural C code and expose it to the fuzzer as if it's a new system call. So for the fuzzer engine, it looks like a new system call with some simpler interface, but implementation of this system call is actually in user space in syscaller itself. So this system call figures out the correct offsets for the rings and does all the necessary writes. And after adding such pseudo system call, we got a number of new bugs in IO ring, and some of the crash stacks actually show that the fuzzer was able to successfully submit some of the IO operations. I think later we could use, since we figured out how to do this type of thing, we could use this for say virtual rings and some other similar interfaces with the kernel. Next feature is called fixed bisection. We deployed it, and the idea is that if we suspect some bug was fixed, but it was not marked as fixed, we can try to find what fixed it. So it's like normal bisection, but it just goes in the opposite direction, and it uses inverted predicate to figure out when a bug was fixed and stopped happening. And if we figure out the commit, then we send an email which says like sysbot suspects this issue was fixed by this commit, and if it looks sane, please mark it as fixed. So we don't do this automatically because sometimes we actually find incorrect commits. We mailed about 80 results with such bisection results, just 80 because some bugs don't have reproducers. Some still happen. For some, bisection was inconclusive. And for some, like they stopped happening on the fuzzer, but when we try to do fixed bisection, we actually see that it still happens on the head. So it just somehow stopped happening during fuzzing only. And next feature is called config bisection. It's quite interesting. So we have this huge sysbot kernel config, which enables lots and lots of subsystems, and it's very inconvenient to work with because builds take very long time. The idea is that we have second config, which is called baseline config, and it's very small. It doesn't include any subsystems. It's just enough to boot the kernel, and it includes debug configs. So first of all, we can check if the crash happens on this baseline config, and if it does, then we found like our much smaller config. But if it doesn't happen, we can try to do a bisection and find some minimal set of configs that we need on top of baseline to trigger this crash. And ideally, we find, say, just one config that we can enable on top of baseline and like then use this smaller config. This has a number of advantages. First of all, builds become much faster, and you do lots of build during bisection. Second, even more important is that this allows to avoid lots of unrelated crashes and broken builds and boots as you go back in history. Because if you disable configs that trigger that crash or that cause broken build, then you don't hit them anymore. So this also improves quality. And we can just provide this config to developers. So this, I think, very nice feature. And the script for this is actually present in the kernel. This is not deployed on sysbot as well for now because we don't have those baseline configs. And I figured out that we actually need lots of configs for different debugging tools, different kernel releases, different architectures, and also this full and baseline. And like we can maintain them by hand. We need some machinery to produce those config more or less automatically. Okay, next thing is we added more automation to Sysbot. That's the things that I used to do manually, and then I noticed that I'm doing the same again and again. So I try to teach Sysbot to do this. First thing, it can remind about non-existent commits if it can be discovered anywhere for more than 3 months. Second, it can auto-obsolete and close bugs if the bug doesn't have a reproducer, and if it didn't happen for at least n days. And for upstream, this n is from 80 to 120. For Linux Next, it's much smaller, and the exact duration depends on the crash rate for this bug. So if it was happening very frequently and then suddenly stopped, then we can close it sooner. And if we had just few episodic crashes, then we will keep it for longer because like we're not sure what happens. And the next feature is auto-upstreaming. So some bugs get staged in on a public mailing list, which is called moderation. And then, for example, this happens for some bugs without reproducers. And then a human needs to go and say, oh, this bug looks good and reasonable, mail it to kernel mailing lists. And previously, this procedure was, this thing was age-triggered, so to say. So if we first report a bug and it doesn't have a reproducer, it goes to moderation. And then even if we get a reproducer later, it still stays in moderation, and a human needs to like say that it now can go upstream. So now it's became, so to say, level triggered. So if reproducer appears later, Sysbot will automatically close the bug in moderation and send it upstream. Okay, now last part about some stats and graphs.
It looks like we have a question, Dimitri. Shua, did you have a question?
Yes, I have a question on the previous auto-obsoleting, Dimitri. Do you have any numbers on how many are you obsoleting the way within, I mean, 80 to 120 days? Sometimes you might not get attention, right? So how many are you auto-obsoleting? Do you have any numbers on that?
I can send you numbers later in the chat. It's possible to find by searching by particular reply on the mailing list. So we can actually get precise number. It will just take some time. I will post it to the chat later.
Thank you.
Okay, so we have a bunch of data on Sysbot. So this is a graph for bug counts for upstream kernel. And the horizontal line is time. It covers 3 years of Sysbot. So on the again, on the left, we have 3 years ago, and on the right, we have now. And this red line is number of unfixed or open bugs. And black and green lines are total number of reported and fixed bugs. And surprisingly, I think those lines can roughly be approximated by straight lines, right, going up. And unfortunately, the dynamics are not positive so far. So ideally, we would like to see them to plateau and then go down at some point. But we still didn't reach this point. So it's still, for now, number of open bugs is just grows. Then this slide is kernel coverage. It covers 1 year of time, and it's super flaky, as you can see. But like my best attempt at trying to approximate it with a straight line is this, and this actually gives quite decent increase in coverage of about 30% in the past year. So this mostly relates to all of those new descriptions for new subsystems. Okay, so skip for now. And this picture, you may recognize this from Case Cook blog post and also some talks. On this picture, Case shows lifetime of security bugs, duration between the bug was introduced and when it was fixed. And the idea is that this graph can give you an idea of dynamics, like if we're getting better at fixing bugs, if we're getting fewer of them. And this is my version of the same information. This
Dimitri,
lifetime of, yes.
Excuse me a sec. On your coverage thing, what exactly do you mean by coverage? Is that percentage of kernel code that's coverage, or the number of subsystem, or what exactly does that mean?
So this is a bit abstract number. This means roughly number of ages in the code. It's like compiler terminologies, basic blocks and ages between basic blocks.
I see.
Like basic block is part of the code without branches, approximately.
I see. Okay.
So it's not trivial to transform this precisely to percent of coverage overall of the kernel, but the delta is meaningful.
Okay.
But then I would say that as long as your coverage is growing, you're not going to see a plateau of open bugs, right? Because if you increase coverage, you expect to find more bugs.
Yes, that's true. But hopefully coverage grows faster than number of lines of code in the kernel.
I just think you start digging into areas that are less traveled, and you will find more bugs relatively than before.
Yes, that's true. That's true.
So that is a good point, Sasha. So it might be interesting to see those two overlap, coverage increasing and then how the bugs are tracking in terms of, because it also depends on if you're increasing the architectures that you're covering or configurations you're covering and the number of trees you're covering. All of those would be the bugs go up. The question is, another question I have is, when you report bugs, number of bugs, I'm assuming that you test several trees, right? So do you find unique bugs when you report them, or is it just a raw count across all architectures and in all configurations and in all trees?
The bugs are merged, so this is not row crashes. Some bugs we have, sorry, this one. For some bugs we have up to, I think, up to 1 million of crashes. So that's what we think is a unique bug with some approximation, like to the degree automated system can classify bugs into different bugs. So there are both false positives and false negatives. In some cases, we have several manifestations of the same bug and we report them as several versions. In some cases, we actually have a single bug, but it hides several different root causes.
Okay, so I think that you will have, when you report a number of bugs, 100 bugs, there might be some duplicates. Is that a correct assumption?
Yes.
Okay.
Actually, on this graph, I do some refining of this because for fixed bugs, we know what commit fixed this bug. And indeed, we have some bugs, some commits that fixed, say, 20 bugs. And if we see that the same commit fixes multiple bugs, then in this particular statistics, we aggregate them into a single one. So at least we know that there were about like 1,800 completely unique bugs because they were fixed by different commits.
Okay, so in this graph, then your black line here that shows number of bugs, that versus comparing the green one, which is fixed. So some of these bugs could be fixed with a single commit, the ones in the black. I mean, based on your statement that some commits fix 20 bugs, say. So is it accurate to surmise from there that the black line you're showing, some of them could be fixed with a single commit?
Yes, correct. So for still unfixed bugs, we don't know precisely if they're duplicates or not. Some are manually marked as duplicates by kernel developers. For those, we know that there are duplicates. Otherwise, we don't know. So there's like, it's not 100% precise. Like gaining this information 100% precise is super expensive. So this is just based on the kind of automatically gathered information. It may have some errors.
Okay, thanks.
Okay, let me get to the last graph. So looked at this. Yeah, for coverage, we also have precise coverage reports with like down to line number. You can find them on Sysbot and look like if your particular subsystem is covered and each particular function is covered. Yes, bug lifetimes. So this is our take on this picture. It's complicated, but don't worry, I will explain how to read it. So first of all, the horizontal line is time, and again, it represents 3 years. On the left, we have 3 years ago, on the right, we have now. The bottom part is latency between the bug was introduced and it was reported. And each dot represents a single bug. So for example, for this bug, it was introduced 150 days before it was discovered and reported. And this bug was introduced 300 days before it was reported. And this cluster at the bottom, it's bugs that were introduced more than a year ago. So they're kept at this level so that we can zoom in the middle of the picture. And again, I will do the same remark that this is based on automatically produce data. So it is not 100% precise, but I think it's kind of precise enough to like get the overall picture. And the top part of this graph is the latency between the bug was reported and it was fixed. So again, for example, this bug was fixed in 150 days and this bug was fixed in 300 days. And bugs over here in this cluster, they took more than a year to fix, so they again kept at this level. And this cluster is not fixed bugs. So overall, this region is kind of good. It's bugs that were introduced and fixed quickly, and those areas are bad. They either took long to discover or long to fix. And over time, this like bugs moving over in this direction would be like good dynamics, and bugs moving in this direction would be bad dynamics. So now hopefully you can more or less read it, okay? And now let's look at like what we can see here. So first of all, you clearly see that the number of unfixed bugs increases over here. And then on the bottom, we're still discovering lots of bugs that were introduced long time ago. So it's not that we're finding just the new bugs. And most likely it's again relates to increase in coverage. As we cover new subsystems, we get those clusters of old bugs. Then bugs over here, it's actually good. It means that lots of bugs have been fixed very quickly within a few weeks. And bugs that took more than a year to fix, I think that the rate is decreasing. But I don't know how to treat it because we're also getting more of unfixed bugs. So it seems that the bugs are either fixed very quickly, just right when they're reported on the mailing list, or they are not fixed at all. And we're not actively working on the backlog of the bugs on the dashboard. And this sparse cluster over here also good. It means that there are lots of bugs that we discover quickly and provide relatively quick feedback to developers. And this approximation of one release time frame, it's approximation because strictly saying it should be something like, I think, so shaped line. But this is approximately 60 days. So this is the bugs, approximately bugs that are fixed within the release and like don't leave the release, which is the best outcome we can have. And there are a significant number of bugs in that region. So that's good. And that's all I have. Thank you. We have like mailing list. We can chat now or like feel free to contact the mailing list. Thank you.
Any other questions for Dmitry? Appreciate some people liking your graphs in the comments. I'm going to switch to the LTP talk, which is connected to the sysbot and syscaller as well, while we wait for any questions. So there's a question about future plans, Dimitri.
One second. Future plans. So it's definitely getting more kernel coverage. Also, I mentioned testing other architectures. We also have lots of plans related to actually making the fuzzer smarter, and that's what I would personally prefer to work most of my time. But unfortunately, I get almost no time to work on this because just have all of those boring problems, and I don't know, things break in the deployment, and people ask questions and so on. So unfortunately, I personally don't have time lately to work on any significant improvements.
So there's a question also about which architectures are regularly covered. Earlier in their chat, there was a pointer to a PowerPC. There's a PowerPC instance of Sysbot running as well. But what other architectures are regularly covered?
So on Sysbot, it's only x86 64-bit. PowerPC instance is run by IBM. It's a separate instance, and I think it doesn't report bugs to kernel mailing lists. At least that's my impression. So it's there. You can look at the dashboard. It probably sends them to some mailing lists. Yes, and other architecture is not tested. I know that people at ARM run syscaller on ARM, and people at IBM run on S390 and PowerPC, and probably on some other architectures, but it's not like they do the reporting, and I don't have visibility into that.
Okay. So if there are no other questions, I'm going to switch to this, to the LTP section of the syscaller talk. Unfortunately, the presenter for this wasn't able to attend this year, so but he sent along some slides that I will just quickly go through. So one of the developments since last year, Plumbers has been actually adding some of the syscaller reproducers to the Linux test project, so that they can be run in the context of a larger test suite. So this is not my presentation, so I'm putting this up here mostly for information. And like I said in the chat, so down in the lower left here, there's actually a download button for all these slides. Anybody should be able to download the slides as well for future reference. So as of this time, apparently the patch that actually adds this to LTP is not merged. It's still on the list, but so it's still kind of under experiment. But it allows to run the syscaller reproducers that actually get found inside the context of LTP. And this is quite useful for other CI systems that are actually already running LTP. So it allows in the context of LTP to find out if these the bugs found by syscaller still exist in the kernels that are being tested by the various CI bots. Various caveats here. In particular, the only x86 is being supported now. But for anybody interested in here, this is still under development on the list, so please get involved. If you're currently running LTP and you're interested in the stuff that the syscaller is doing, this is a great place to get involved. Oh yeah, and the kernel actually has to have a set of options involved. That was actually one of the questions I had for you, Dimitri. Is there a place where you publish the kernel configs that are required or that are needed for the standard sysbot runs, or the set of def configs, I guess, that you're using? Because those would be needed.
config is provided with every bug report that we report. For reproducers, there's no single config, but our sysbot config is generally, it's only growing over time. So if you take kind of the current sysbot config, then that's most likely what will reproduce the bug. We never try to do this config bisection and actually find kind of the minimal set of configs that they correspond to a particular bug.
Okay. So the report itself has a config in it that can be grabbed?
For sysbot, yes, but this is lost in this reproducers repository. But the idea for that one is that you say you run it on your target kernel that you care about, and if you cannot trigger a bug because you don't have a particular config, then like that's the answer. You're not subject to this bug.
Yeah. Okay.
So I'll ask. I have a question, follow-on question to Dimitri about the configs. So if somebody wanted to run the reproducers that we are currently have on the Linux orgs, I think that's where LTP is pulling them from as well. Do you recommend a minimum configuration for those reproducers to effectively run syscaller?
So for reproducers, like as I said, if you're testing your kernel, say your distribution kernel or your device, then you just use that config that you use in production, or most likely you want to enable some of the debugging configs.
Mm-hmm.
So that may correspond to your, say, testing config, right? If you're testing with, I don't know, logdep enabled, you can use that config to run reproducers. And then automatically, as I said, if like some bug is not applicable to your kernel because you don't enable a particular config, then like that's good.
Okay, so no minimum configuration. You don't depend on. Yeah. Okay, thank you.
For just testing, say if you want to test an long-term release, then you can take the sysbot config, which is the kind of the largest config with all of the configs enabled for all of the subsystems, and that should be a right config.
Okay, sysbot config, using that with the reproducers repository should work. Okay, yeah, thank you.
So one of the interesting things I think in this slide that caught my eye is and to actually run these reproducers in like a CI bot system, the recommendation is actually to reset the system kind of between each test because the tests are essentially made to crash or to have kind of potentially unintended consequences, right? So that makes it, especially for testing on hardware, that makes running this set of reproducers fairly time consuming, right? Or it could be time consuming if you're crashing every test.
I'm not sure why you need to reset it each time. It's like if you're just interested in like, yes, if you want to attribute a particular crash to a particular reproducer, then yes, it may be useful. But if you're just running all of them to get crashes, then you can just run till the first crash.
Yeah, I think the first example is the more interesting one for the CI bots, is to find which reproducer actually caused the crash or yeah, caused the hang or the panic or whatever.
Yes, it's tricky. During Fuzzing on syscaller, we have reproduction as separate steps. So we run lots of test cases in parallel. Because it's impossible to attribute crash with the test case anyway, because some happens asynchronously or some relate to accumulated state in the kernel. So we have this localization of single test case as a separate step when we take the part of the tests that will run just before the crash, and then only for those tests we run them one by one and try to find like the one guilty one.
I see. Okay. Yeah, I think that's it for this. Yeah, so like I said, this was sent from Richard, who's working on the LTP project. Here's his email. So yeah, the feel free to reach out to him directly or get involved on the mailing list for that particular project. Any other thoughts or questions on the sysbot, syscaller, LPD, LTP reproducers? A couple comments in the chat. Oh, okay, you sent there's the def config in the chat there. Okay, cool. Okay, while we're waiting for any last couple questions, I'm gonna switch over the presentation. I think, Tim, you're up next.
Okay. My audio okay?
Yep, you sound good, Tim.
Okay.
Let's just wait. Let's just wait
Yeah,
one more
wait 1 minute.
We're starting on the time schedule. One other question from Case in the chat about Ubisoft. Okay.
Hey, Dimitri, while we're waiting, can I ask if you have a more concrete timeline on GWP, Hassan?
We want to send it when the current merge window just settles down, just to not bother people during merge window.
Cool, thanks.
So that's the plan.
You have a question, Guillaume?
Yeah, about reproducers. When you run a series of reproducers and none of them trigger any problem, is there any chance that sometimes it changes the state in a certain way and then something else will fail, even though the reproducers didn't actually trigger the thing they were trying to reproduce? Have you seen this in practice?
Can you clarify what? So what exactly is the situation?
Well, because when you run some system calls, if there's a subtle bug in the kernel, it can change the state. Like something might change a value somewhere. That doesn't cause the problem that the reproducer is trying to reproduce. But then later on, another problem will happen. Like if you run them in a different order, maybe, or if you skip them. I mean, that's a problem you can see with other test suites. Like you can run a series of tests, they all pass and one fails. If you run that one on its own, it doesn't fail because it's, the state changed. I guess it's a bit related to what Kevin was saying with rebooting. But even if the system, even if you don't cause a crash, have you seen in practice cases where the order when you run reproducers, even if they don't trigger what they're trying to reproduce, when they've actually changed the result of subsequent reproducers being run?
Okay, I got the question. Yes, it happens, and we have what I describe is very simplified procedure. The actual procedure is much more complex. So we first try to run test cases one by one for short duration. Then we try to run them for longer duration in case it causes a hang that is detected only after, 3 minutes, or it's a data race. And then we try to run all of them at once. And if that produces a crash, then we try to do a bisection on this set of reproducer and say try to throw away first half of them and then second half and like some parts and just ideally we find maybe 2 programs to test that trigger it, but sometimes we find like only large combination of them run together, it produces a crash.
Okay, thanks. That's great.
Okay, Tim, you are now the presenter. It's all you.
Okay. Hey, I'd like to say hello to everyone. It's good to, well, not be with you, but be with you. And it's good to see a lot of familiar people in the virtual room. Anyway, I just have this proposal that I want to throw out here. This is going to be a quick session. Standards for device-side test artifacts. and I'm going to skip past the abstract. I want to give the proposal and just kind of talk about it a little bit, and then hopefully get to some discussion. So the proposal in abstract form is I'd like to declare a standard for how to detect tests on a Linux system, how to execute a test, and how to find tests. And so the actual proposal in detail is pretty short. This page is basically the entire proposal. The stuff in red are the key parts. So I'd like to create a new standard directory in the Linux file system hierarchy called user test, with a subdirectory user test bin. And that bin directory would be a place where we could put tests, wrappers, and test specific utilities. And I'd like to, underneath user test, have a subdirectory for each test suite with the name of the test suite. And then inside the bin directory, I propose that we have either the test executable itself or a wrapper that can run the actual test called testname-run. Part of this standard is if we're creating a place to put things, we need to have user and group for them. And I propose that we use define a new user and new group called test each respectively with UID 88. And then the other thing is that, well, so these would be the default owner and group for items that were in the user test directory. And then the last part of this would be to define some place for test results. I'm proposing either var test, or depending on discussion, if it fits okay, we might want to put it in var log test to avoid putting too much in the top level directory of var. And then for test results, if they go to a log, a lot of tests just do stuff to stand it out, but if tests have a log, that the log have a format that is, the file name have a format that's easily determinable, test name-test timestamp, and we could discuss the details of what an appropriate timestamp looks like with some extension. So if it's JSON or XML or text or whatever. So that's the proposal. So kind of digest and think about that while I talk about a couple of other things. So what does this solve? Well, it allows test frameworks to find, enumerate, execute, and retrieve results from installed tests. So just like there's a lot of things in terms of packaging, the distributions package, where things kind of just show up in a directory, and that means that the system knows about them. And so I kind of want the same thing for tests, so that tests can be added or removed from the system, and then things that use those tests, including humans and CI systems, can automatically detect them and be able to access them and run them, etc. What another thing this does is allows for test artifacts to be stored separately from production binaries and data. So out in the field, there's you have a lot more constraints, especially in embedded products, consumer electronics products. There's not a lot of room for tests, and so a lot of tests are installed kind of during QA phase, but are removed when the product ships. And so there's a lot of examples of tests that are kind of too big to stay resident in production devices. LTP is a good example. And so this also allows you to select the test storage policy that's appropriate for your product or usage scenario. So you might put tests and text executables in like a temporary area, or you might map it. You might actually have them on a remote drive that's mounted remotely, so it doesn't take up space inside the product file file system. Anyway, so a couple other things that this solves is that a predefined test user and group would allow for more consistent test execution. Right now, I think the basic pattern is that most tests run either as whoever the user is that's running them, or as root, and that means that some test results that could be dependent on permissions might act differently for different people. But if there's a test user account that's predefined, that makes the permission checks more consistent. So that it wouldn't be subject to the vagaries of different users and their permissions. Also, it allows tests and frameworks to be able to rely on a non-root user account. So that's one less thing that automated tests have to configure or set up. Then another thing that would be nice is user test bin, and maybe if we added this to the spec, something like user test lib can serve as a place to store common helper tools and libraries. So utilities and tools that are found to be useful by one CI infrastructure, if they're under user test, then those could be something that we start to recognize as useful for more than one system, or and so we can start sharing. And then var test is the idea there is to allow users and tools to be able to find results. So if we have a consistent place where test results are logged, then that means that the CI systems can know where to look for them, instead of just having it be ad hoc as it is today. So my vision here, it'd be nice to create an ecosystem where end users can easily execute tests and send results. And it'd be really nice if test frameworks could automatically find and execute tests and collect results without having to agree between them on the other aspects of the test definition. So I wanted to look at the existing landscape, compare this proposal to what is kind of already out there. This is not comprehensive, but I took a look at LTP, and LTP has both Linux and POSIX tests, and actually some other tests that don't fall in either of those categories. But and then a Yocto P-test, Debian auto package test, and Fuego. And I want to look at this really quick because I do want to leave time for discussion. But basically, in the existing landscape, LTP, the default directory is to put itself up into opt LTP, and the test cases, the individual programs are in test cases bin. Or if you're running a suite of LTP tests, there's a file in opt LTP run test, and then the command and the arguments are specified in the run test file. And LTP POSIX tests, they're in a directory under opt LTP conformance, and then all of the test cases have a consistent extension dot. It's the test case name dot run dash test is how you find those. For Yocto P-test, they put their stuff under user lib in the package name, so they're kind of integrated with the individual packages in a directory called P-test, and they have each one has an executable called run-p-test. So that's how they've standardized. Debian auto package test for the packages that include tests. The test, they'll be on the target directory called Debian test name, and then specified in the Debian test control file will be the name of the executable. And then Fuego, which of course is the CI system that is near and dear to my heart because that's the one I maintain. We put stuff under home Fuego. Actually, that's configurable. It could be home test or other places, and then Fuego dot test name, and then the actual test executable is specified in a configuration file. So the proposal, if you compare and contrast all those, it would be to put this stuff under user test bin and have a directory for test materials and metadata under user test name. Be able to specify a user as either root or the actual test user account, and then to always be able to find a test executable to run by having it with the same name -run as the test suite. Okay, so what are some of the issues? Anytime you're auto-detecting and running stuff on a system, there's some security issues. So user test bin could introduce a new location for malware injection. This is something that all of us are dealing with in our CI systems, which is how to deal with automatically running stuff that you get from third parties. And this would be really kind of no different from that. But there is this actually does, I think, help in that regard, that having user tests separate from the rest of the production system may allow us to do easier fencing of the test executables, and so that's something to consider. But that's a discussion point. In terms of storage types, if what this allows is for people to put their test artifacts in different storage, if they want to. So read-write versus read-only, persistent versus temporary, local versus remote, and kind of keep those separate from the production system. But people would actually have to implement that in terms of like distribution install. And so that's kind of a policy up to the end user, but it'd be interesting to see kind of what that means, if that's beneficial or not. And then the results output format is kind of a too big discussion to have here. This is not proposing a standard for the results output, but one note to take here is that it would be nice if each executable had a single output that it created. So whether that's TAP or Kernel CI or JSON or XML or whatever it is. So in the case of LTP, right, which has multiple different styles of outputs, most people are familiar with the Linux tests and the LTP format for those. It'd be useful to have two different, even though you have a single LTP installation, it'd be useful to have two different binaries, one to run the POSIX tests and one to run the Linux tests, so that you could distinguish those in the system in terms of output for parsing output and stuff like that. Okay, so how to proceed? Basically, I'd like to find out if there's any interest in this, find out if there are any existing standards, if anybody knows about stuff, that would be good to know, and then start to discuss additional items. So there are additional things you might put in there, like if you have libraries, to put them in user test lib, or if there are man pages specifically for some of the testing utilities, put them in user test man. Maybe conventions for command line arguments for different output formats. I think basically my goal is to add this into the file system hierarchy standard, and then, well, and maybe not in that order, promote this to distribution vendors and build systems. So go out and kind of convince people to do this, and I'm not sure what comes first, the standard or the convincing, probably the convincing. But the first thing I want to do is take a quick poll just to find the interest level. So I'm going to start a poll here. And so read through those options. Your options are, in terms of your interest level, are you interested and willing to adopt this? Do you think it's great? And then, sorry, let me actually work on the poll here. Okay, so let me get the poll out there. Are you interested, but kind of you probably don't expect to do much yourself? Would you kind of want to see what happens with it, see if it gets any traction? Do you think that there are some big changes needed, or do you think this is a bad idea? So that's the poll. I'll wait for just a few more people to. These polls come up quick, and you have to think through a lot of stuff sometimes to answer them. But I am seeing responses pour in here. I didn't do the option F, which would be Tim, stop bothering us with this stuff. So, okay. So I think I'm going to go ahead. I'll give 10 more seconds here on the poll. And okay. And there. Okay, so this is the results. So it looks like there's a healthy amount of interest. A good number of people in the yeah and okay categories, and a lot of people in the wait and see. So nobody said nah. So that's encouraging. So just I want to open it up. So someone had come on as video, and I didn't stop because I was in the middle of the poll. But person who came on, did you have a question? And I'm sorry, my chat. I'm gonna get back to my chat and maybe look at the questions. Okay, so next thing up is discussion. So yeah, Lewis, what?
So I think it might be easier to instead try to convince folks working on different test frameworks or platforms to adopt to this, to simply have a third-party type of solution that has a mapping for symlinks for this. That way, then the standardization is done in place as a helper for all of these different test frameworks.
Yeah, that's actually a good idea. I think one way to approach this is just to do a set of wrappers on the existing stuff. And I don't know if there's a whole lot of churn, like the Octo P-test stuff. I don't recall the number of packages they have that already do this, and they already have a well-known place where they put their materials. And so maybe if you just had symlinks, that would be sufficient. One of the problems, of course, is that each CI system, right, the Debian CI system or the Octo CI system, they already know where it is. So there's no incentive for them to go out and kind of modify that. And in fact, it's extra work for them. But maybe you could do like an adapter package that layered on top of their existing system some of these standards with, like you said, symlinks or something. Okay, so Mark, you want to?
Yeah, so there's been a bunch of discussion in the chat suggesting putting it, rather than dumping things into /user and other standard directories where the distro thinks it owns everything and it's likely to get upset if something goes and messes with it. It'd be better to put everything into /opt/test or something like that, because opt is the directory that the FHS reserves for random extra stuff outside the distro's control. So it'd be safer to do that probably.
Okay, that's a good idea. Yeah, I'll think about that. Yeah, opt is a good place. That's where LTP goes, and it's kind of big. Nikolai, did you have a comment?
Yes. So the scope of those tests would be the platform tests, or anything higher like application tests, or what's the scope?
Yeah. So this is I view it. The scope is really it may be more about user space, but I could see like K-self tests being put in there. So I mean, I wouldn't want to limit and KUnit. So I wouldn't want to limit it to just application or high-level tests. So to answer your question directly, I'm not sure what the scope is. I think that's a good question. So it looks like I'm out of time. So let's take this offline and appreciate the feedback, some good ideas, and I'll turn the time back to Kevin.
All right, since you made a segue from K-self test, let's take advantage of that. To Shua, you're up. Are you ready?
Yes.
Okay. I will make you. Oh, I need to make you presenter. And there you go. You should have all the powers.
Okay, that sounds good. Okay, so just want to give a quick status and also open it up for a discussion on running K-self test in test strings. That's kind of has been the objective for a couple of releases now. Just want to get that discussion going on and next steps. So quickly, intro on K-self test. K-self test is a, people keep asking me what is K-self test more often than not. So K-self test is a developer test suite for kernel developers and kernel users. Primarily it is in place. It is part of the kernel Git. The reason for that is we want to be able to features, so that the features and tests that go along with the features can go at the same time in a way that we are making those available. So that the test development and the feature development can happen together. So what is in K-self test? It is a collection of code-based open box type tests, and then behavioral tests, which are closed box type tests. What that means is that you will be, some of the tests are in the sense that the code, the author of the test will have the knowledge of the code. So this structurally depends on the knowledge. So behavioral tests is where you are just testing the behavior of a function or a feature. So it also includes functional and feature tests. And we have a mix of hardware-specific tests and some driver coverage, which is a continuously in progress. We don't have as many hardware and driver tests at this point. And a few stress and performance, that area could use improvement in various subsystems. Some subsystems have some performance tests, but it could use coverage there. So I have links on where you can find information, and then it's a patchwork project. I'll also Git as well. All right, so what it's not for? It's not for testing workloads, not testing for application type. This is strictly for testing kernel features, kernel API, regressions, and some driver-specific tests. Kernel features and API, the scope and focus is, like already mentioned, kernel features and API, kernel functionality, regression tests, and we have several subsystem specific tests. We continuously keep adding tests. And kernel developers are primary authors of these. As they write new API or enhance new features, they add tests specific to those, and kernel users as well add tests. And then, it's the same set really. Kernel developers use it heavily. The way kernel developers and kernel users use these tests is a little bit different. Kernel developers focus on their own area, subsystem specific tests that they want to exercise. So that is, is in a way poses some problems. That is the nature of the test that will never change. However, that is the same thing that makes it difficult for us to support it on kernel CI type rings. So how do patches flow? The patches flow from all subsystems, really. The reason for that is it is by design, it's not by an accident, because subsystem tests have dependencies. Features dependencies on their main tree. So that is by design that all of the patches will flow with the features as needed. If there are no dependencies, and if it's a framework thing, I pick them up and take them. But for the most part, the reason is that we want to allow keeping the features and tests grouped together as they flow through the tree up to Linus's main line. And individual test view, you'll have a main test, which is usually a subsystem directory target. You'll find MM. When you go and look at it, you'll find MM timers and various they're not necessarily totally tied under the subsystem hierarchy, but loosely tied with the subsystem hierarchy. And then under each main directory, you will see several subtests, and under that, individual tests and test cases. So there are several tests to run starting from the main hierarchy. And we keep adding these tests at every release. There are tests going in, new tests going in at the top level, and then also enhancements to existing tests. So the challenges. The challenges is really common. We continue to struggle with evolving common framework, flexible for customizing tests, and then increasing coverage. Those are the two things we struggle with. And we are, I think, in a good place here. We keep making changes. The recent changes went in. Case Cook and Paulo have done work in updating to TAP compliance recently, 5.8, I think, that we did that work. And then we keep continuously keep doing that. And then I kind of have given up on this because we have so many tests now. I'm not really looking at the time. It's more important to run the tests. So at this point, it's not a big priority for me, holding the time, runtime. It's more important to say selection of tests. That's something that have tailored the time to runtime to selecting specific tests. That's probably more of a goal right now for me to work towards. So this is where the big challenge is that we are facing right now in terms of getting K-self-test running in kernel CI environment, balancing the kernel developer and user use cases. They are different in the sense that kernel developers want to focus on running tests for their subsystem and then get that done and move on. Whereas users want to be able to not only build these tests in native as well as cross-build environments, and also be able to install them on a target. In a way, it's not just installing, copying these build objects, the tests that are built. You also need a run script. So that's where the install part of this test, K-self-test comes into play, especially supporting this in the kernel CI and other test string environments. So I touched on these use cases. So these are the specific use cases for being able to get K-self-test running. I think LKFT is doing that already. However, in a way to more automated, more not without too much manual intervention, running these requires changing the framework and supporting these in a, say, in a more clean way that we are not really going and trying to tweak things, right? So relocating builds and so on. Same use cases, people want to run individual tests and a subset of tests and all tests at once. So all tests is probably the more of a use case for kernel CI and other test strings, and also subset of tests. There might be there is a need for test strings to say, I want to tailor some of these tests to my specific architecture or specific configuration. We have some support for that. That support needs to be refined and improved. I'm going to skip this one, and then what's the status of running the tests right now? As far as I know, LKFT does run tests that on K-self-tests. They run it on Linux Next, Linux mainline, and stable and also active kernel releases. And they send reports to the stable mailing list. You can see that, and pass-fail counts. So, that is that. And then a 0-day runs them. And I want to get to kernel CI. So this is really my primary focus of this coming here and talking. So I do know that kernel CI use cases, they want more support from the use cases. I want to discuss that. This is kind of avenue discussing that and then figuring out what we need. And I have done some work in 5.6 release specifically. I went and did some work in terms of getting all of the tests building in a cross-build environment. And one of the challenges is that as new tests come in, new tests might not always. It almost feels like you're shoveling snow while in a snowstorm, almost. So some of these new tests, we don't catch them, and then we keep increasing them, improving them or fixing them. So I haven't honestly looked at it. I wanted to take time to take a look at 5.9 status, but I didn't get a chance. But as of 5.6, this is the status. Cross-native and cross builds are supported. except BPF. BPF has dependencies, so I would exclude that currently from the discussion of getting this going on Kernel CI at the moment. And then another thing I have done is being able to do dependency checks. I wrote a script, kselftest deps.sh. It's already in 5.6. What my intent with this is, when somebody is going and doing a cross build, being able to check their system and say, hey, do I have all the dependencies for each of these tests for me to build, do a cross build on that particular development system, wherever you're building that. So that works. I have put in features that I thought would be useful for me as I'm doing the build. That could be improved, and if there are the features or options that you would need for your tailored to your test strings, please send patches to that. Currently, what it does is it prints the test targets that can be built. It will just say MM tests, for example, or networking or timers and few texts, and it'll go and say, these are all the things that can be built based on the libraries and packages you have installed. And it'll also dump the dependencies out and saying, for this particular test to be built, you will need these libraries. Some tests depend on libraries, some libraries installed, LiveMount, for example, or other things. Kevin, do you have a question?
Is that dep script also working for the cross-build environments?
Yes, that was my primary focus. So that's why I did that. It should be working. If I tested on a couple of cross-build environments, I think PowerPC and ARM64. If it's not working, we should make that work.
Okay.
That's my goal. Yeah.
I saw that existed, but I assumed it wasn't working for cross build, so I need to check that.
Yeah. I tested it to verify my ARM64 cross build as I was doing all this work. So it does work on ARM64. PowerPC, I did that on PowerPC because I ran into, maybe S390 as well, because those are the three things that I ran into some flags issues with cross build. As I was fixing those, I went and tested this dependency script on those. But I haven't covered all of the architectures, but it'll be great if you can try and let me know. And send patches, or that'll be great.
And then also on the relative path stuff. So this is the thing that I've been hung up on a couple times. Can you go into a little bit more detail of what the status of that is, or is it working in Next but not in mainline or something?
Yeah, I haven't. It's work in progress. I haven't. I have a couple of patches that get it to work. I think actually Masami's patch does that for ftrace. I have to take that and then get it to work for all of the tests. It's not just, go ahead.
It seems like every time I try it, it might work. And then as soon as a couple more tests are added, then those tests break it again. So that it needs to be a part of the common make stuff instead of the per test stuff.
Right. Yeah. It has to be the common stuff. So, and then also, like, this is the same, the comment you made. Yeah, when new tests come in, they break. So it's so that's like, that is ongoing. But I haven't. It doesn't exist yet. It's I have been working on it, and then I haven't gotten time to push it yet. So is that a big block? Is that pretty much the blocker for you? Or can you do anything? Make any progress at all?
We're able to build it. It's just that the build seems fragile, and we have to do some contortions in our build system to kind of basically trick and it potentially can mess up other parts of the build. So that's why I was asking him.
I see. Okay.
We do have we're able to build now, but it's a little bit kludgy.
Okay.
And it seems like it's not going to survive kernel revision up as the kernel evolves. So.
Yes. Yeah, that's ongoing. Ongoing, like the shoveling snow type thing I'm talking about. So you could also, one of the things, if you want to, as for reducing, I saw a 5-minute warning, I'll just wrap this up quickly. cross builds for specific subsystem, you can also use targets variable. So go ahead and take a look. I use that heavily when I'm doing work in K-self-test in terms of testing stuff. And then there is the K-self-test merge that can be used to generate kernel configuration that includes individual tests. Cross-building for specific features, on the other hand, is going to be very tricky to implement, because within just a subsystem, there will be, within an individual test, they depend on config features sometimes. And then the features of a system call itself, you might have different specific features within a single test. So that's going to be very tough to achieve. I am going to go through these, and then I'm going to open it up for discussion. Kevin, if you have any questions specifically, I think you already told me what your pain points are. We need to, I know we need to get to a point where you can start running them, and then we can start improving them as well. So if there is any blocker for you, let me know, and we can work on that first.
So there's, I think, there's some comments in the chat that a few places are running them. So CKI is running them. LKFT has been running them for a long time, as you already mentioned. I think the tricky part, and where Kernel CI, we've been leaning heavily on what Dan and the LKFT team have done with the skip list. And so I think that's like a really interesting place to collaborate, because there are tests that just don't run or will never run on certain platforms, or they always fail on specific platforms. So kind of collaborating on that criteria, documenting that criteria. We're using the test plan that Lenaro or the LKFT did, so we kind of are sharing their knowledge there. But for people that aren't using Lava or kind of those type of test definitions, they must be doing the same thing. So I think that's a potential collaboration point, is to make sure we're not duplicating effort on kind of coming up with those skip lists. And especially knowing why we're skipping tests. It could be that the tests will never run because they're architecture specific. It could be that the tests are broken and not being fixed. And so there's lots of reasons there that I think could use a bit more collaboration.
Right. Skip in general, the skip within the framework definitely is because the test cannot run for various reasons, because you might not have config, or you might not have. Skip is never a failure. We made that very sure, because if a failed test is very different from a skip test. But for some reason, you are needing to skip it. Skip at what level? I guess I would ask that question. If this is skip directly coming from K-self-test, it's never a failure. It's always that you do not have a test module, because K-self-test also has the library test modules part. So some of the tests load a library and then run tests, load a module and run tests. I'm sorry, I meant to say load a kernel module, test module, and run tests. So if for some reason the test module is not present in the kernel config, we do not call it a failure. We call it a skip, because we cannot run it. So
yeah, I think that level, the framework level of skip is good. I mean, it provides the infrastructure to do that. But on top of that, the test run, the people that are wrapping this in CI frameworks are adding another level of skipping for several types of reasons. They could be architecture specific, they could be board specific, they could be kernel version specific. For example, suspend resume doesn't even work on a particular platform, so we're not going to run any suspend resume tests. Right. Yeah, and Dan just put it in the chat there, so the skip list that they're using for LKFT. So that's the type of thing. And so the way that's working now is it's just kind of documented in comments in that file why LKFT is skipping the test for various reasons, and that's useful, but that may not be useful for CKI or for other people that are running LKFT. So I wonder if there's a way we could do that type of stuff for that could be shared between other more frameworks. I guess that's the thing that I'm pondering, how to do that better.
Right. So Dan and Anders, they have been they worked through all of them for the last 3 years. Dan, they have been working to get these tests running, and they sent a lot of fixes in as well. to get it going. So framework improved a lot because of their work. So looks like Sasha is going to tell me that I'm running out of time. So thanks, Sasha. So well, let's move to the chat channel. Kevin, I really want to get this working. So for that, let's collaborate and get this working, and we can work with Dan and Andrews as well, at least sharing pain points and then getting this to work.
Okay,
Thank you.
so let's stop there and continue in the chat. We're going to take a break, and we'll be back in about 15 minutes at 20 till the hour. So yeah, let's take a break and refill our beverages and stretch our legs, and see you back in a few minutes.
Thank you.
I think Guy requested that Luna joins the micro conference.
That's cool. I have another dog here.
Nice. That's awesome. So cute. Thank you for sharing.
She's here.
You should invite Laura over. Oh, she doesn't want to be here.
No, she doesn't. She doesn't want to be here.
That's funny. That's fantastic. We should invite Laura. I don't know if she's here. She might be in another room. Katie's here.
Yep.
Others. Thank you for sharing.
Okay, we're almost ready to get going again. I'm going to get the next presentation queued up.
All right, just give me the signal when you want me to start.
Okay. Okay, you are now presenter, Brendan, so take it away.
All right, cool. Thanks. All right, so yeah, last year I gave a talk introducing KUnit at LPC, and I thought it might be appropriate to give a sort of 1 year, like 1 year later, what's changed in that time. So in case you don't know me, I'm guessing most people here probably would know me from my work on KUnit, but if not, I also used to work on OpenBMC, so yeah. So I don't know why my keyboard controls aren't working. So I have one slide on context. This is probably not going to be a super interesting talk if you've not heard of KUnit before. It's just unit testing for the Linux kernel. I've given a couple talks on it in the past. Obviously, there was one last year at LPC. I'd recommend going and watching one of the either my Plumbers talk last year or a talk I gave at LCA if you want to know more about KUnit. I probably should have also linked the kernel documentation here or our website, but whoops. Anyway, so since last year, I probably should have made the first slide that KUnit was merged in 5.5, since actually when I presented on this last year, KUnit was not yet merged. So I think that's probably the most significant update. So it was merged in 5.5. Since then, I made this graph to track sort of the red line is the number of contributions to contributions not from basically me, David, or other people at Google, directly to KUnit itself. So it also doesn't include tests. So it's basically like changes that affect the KUnit framework or tools. The blue line is the number of unique contributors, people who've contributed to the KUnit code base. Again, not counting test authors. The green line is test authors, and the yellow line is the total number of tests. And for every cycle except for the very first one, the number of test authors and the number of total tests are the same. I also should mention total number of tests. I counted files containing KUnit tests. The reason I did that instead of, so KUnit also organizes it has individual test cases, and it groups those into test suites, and there can be multiple test suites per file. However, the vast majority of tests only have one test suite per file. And files that have multiple test suites have a tendency to, they tend to be pretty closely related, and it was just a lot easier. I wrote a script to count all this stuff up, and it was just easier to count the files that contain KUnit tests. Yeah. So looking forward, like trying to predict trends, we have about somewhere between 5 and 10 new test suites, test files that have been proposed on the mailing list. Reason I listed 5 and 10 was I know of 5 that are actually being worked on that I would expect to get merged soon. And there's a couple others in addition to that kind of have an unknown status. So that would bring us up to about 7-ish, I think. So I figured somewhere between 5 and then round up 10. There's also a large number of test conversions underway. We have a couple of Linux kernel mentorship program mentees who've been working on some test conversions as well as some additional new features for KUnit. So you would expect that to increase the total number of tests. And we're also still seeing contributions from people other than David and myself. I should also mention I work on this full time with David. I'm going to put him on the spot later in the presentation. You'll get to hear him. But I work on him, and we just brought somebody on to help us work on another feature that Google wants. So right now it's 3 of us working at Google, but we're getting still seeing healthy contributions from people outside of Google. So I think those are all pretty good indicators that the numbers that I guess the graph that I showed on the previous slide will continue to go up. So takeaway for me, I think that it seems like there are people who think that KUnit is useful, which is good. I was kind of hoping that test adoption would be faster, but I don't know. Given all things in consideration, I don't know that was an entirely reasonable expectation. I don't think that the adoption numbers are something to be super proud of, but I also don't think there's something to be ashamed of either. So it's, I guess, just sort of okay. However, the contributions from people outside of me, David, and Daniel are vastly exceeded what I expected to see. I was really kind of humbled to see that there are people who actually felt strongly enough about what we were doing to add things to KUnit. So that was pretty exciting. It still is exciting. But I think that's also illustrative of if people, the fact that I think that we're seeing more contributions to improving KUnit than we are seeing new tests from KUnit, to me suggests that KUnit has a lot of room to grow. Otherwise, those people would probably be more focused on writing tests with KUnit, or that's what I would assume anyway. But I don't know. Maybe they have other reasons for contributing to KUnit. So overall, I'm pretty happy with just looking at the numbers since last year.
Looks like we have a question from Shua.
Hi. Yeah.
Not a question, Brendan. I would say you guys are doing great. A lot of tests, number of tests, you're focusing on testing subsystems. So not to be concerned about. You should be proud. You all should be proud of yourselves.
Oh, thank you. Yeah, I don't know. I guess Shua, you'd be sort of one of the few people qualified to make an assessment on that, because there's not very many people who I think have tried to add a new testing framework or library to the kernel. So coming from you, that means a lot. I really appreciate that. Yeah, sorry, I forgot about the whole, like, raise, unmute yourself to ask questions. But yeah, please feel free to make comments or ask questions at any point in my presentation. That's the way I prefer it, because I don't think I'm the best presenter or anything, but I think it's more interesting when it's a dialogue. Oh, we have a question. What work has been done with? Mocking. Yes, I will get to mocking. I have a slide on progress on that. Yeah. So new features. These aren't all of the new features we worked on, but these comprise the majority of features. And I wanted to talk about all these together because, well, first off, these were all features that were contributed by people other than myself, David, and Daniel. Module support, you can now run KUnit as a module, or KUnit tests as modules. You can build KUnit tests as modules, load them, and the tests run. We have debugfs support, where originally, and KUnit still prints out test results to dmessage, but you can also get the test results in a structured format by looking at debugfs. There's also, so the ones with asterisks are things that aren't like totally done, but I wanted to group here, and I think they're probably going to land pretty soon anyway. Module only / user space tests. we recently, one of the LKMP people, Vitter, I don't think he's here, but he had the idea to add support for, basically there are some tests that can only be run as modules because they need access to user space, or a MM context with user space context attached. I'm not sure what the correct terminology is, but anyway, it's basically a way that you can launch module like KUnit tests as modules from the KUnit tool inside of UML, which ended up turning out to be a really, really neat feature that I would have never expected to be something that was actually useful. So the other things are there's been some work to kind of better support multi-thread or multitask unit tests. Traditionally, unit tests are only single-threaded. There's some exceptions, but I don't want to go too much into that. But basically, there were a couple features that were introduced that better support having unit tests that involve multiple threads or tasks. And the thing I thought that was really interesting about that is, first off, none of those were contributed by people, you know, for any of the me, David, or Daniel. And they're all kind of integration testing related things and have been used to write tests, which I would consider kind of either full-on integration tests or borderline integration tests, as opposed to unit tests. Last year in my presentation, I had sort of like broken down this dichotomy of KUnit. I would put clearly like within the space of unit tests. K-self-test I would put mostly in the group of like functional or end-to-end tests. I know that K-self-test is broader than that, and also kind of stretches into the integration testing realm and some other things. And I don't want to like. I know that it's a broader thing than that. But anyway, I'd kind of left the point of integration testing as sort of like an open question. And it was really interesting to see that that is something that totally developed outside of any, like I didn't put any kind of direction behind that at all. In fact, I had actually originally kind of discouraged that because I was sort of afraid it would take KUnit in the wrong direction, but it's just been really interesting to see that kind of come out. I don't want to say on its own, like, you know, clearly there's like a project here and people have you know, their own agendas and stuff, but it was interesting to see that come out where I had like, you know, didn't intend for that at all. So some other things, I guess this is less of a feature, but there was a really good discussion on KTAP. I was kind of hoping that Tim Bird would talk about this more. I was expecting he was going to bring this up in his presentation, but the takeaway from me with that is it's exciting to see that there is more standardization of test output for at least within tests that exist, that live within the Linux kernel source tree, between KUnit, K-self-test, and the fact that we've seemed to have been mostly getting away with trying to convert things that are neither K-self-test tests or KUnit tests to converting them over to KUnit tests. Oh, we got another question. My question is about integration testing. I've done some pretty interesting integration testing with bare metal, RTOS with gtest and gmock. Okay. Sorry, I'm not sure what the question is. Oh, is it on the radar? No, I haven't considered doing anything with Google Test and Google Mock. I know that I'd I had referenced Google Test and Google Mock within the KUnit documentation, but it was more of inspiration. I heavily borrowed from a lot of their API decisions with KUnit, but there isn't any like real connection there. I'm not sure if that answers your question. We should probably maybe have some more discussion later on if people are interested in that topic. So also update on Kernel CI. So we had Google has this thing called engineering residency. That it's kind of a program that's available to new grad hires where they can go and work on a couple of different teams for a couple of quarters. We had somebody who was working on KUnit who made a ton of progress in Q4, Q1, and Q2 on Kernel CI, and we were almost there, but unfortunately she had to leave us. So I started working on it again in the last month, but I've been really busy and haven't finished it. But it seems like we're pretty close. So update on mocking. We've not made as much progress on this as we would have liked. I would say so. I don't. Maybe this is unfounded, thinking that there's less upstream interest than expected. I know we haven't actually, like, aside from the initial RFC, which was way back when I originally proposed KUnit. There hadn't been a lot of discussion on it, so maybe that's unfair. But we did have one person upstream who's recently volunteered to help work on it with us, and also we recently got some internal funding from Google to have somebody help work on mocking. So we expect to see a lot of movement on that soon. So that's not really a whole lot to show for it yet, but you should definitely see some movement on that soon. So I also, we learned a lot of things over the last year, and way more things than I have time to go through. And I'm actually a little bit behind on time for my presentation. So, but I thought some of these things were kind of interesting, because I think some of them are sort of like illustrations of kind of newbie mistakes, but are, I think, kind of still informative regardless. So on the topic of KUnit tool, early on when we first proposed it, it seemed that there were a lot of people who didn't care for it. I wouldn't say we really got anyone say that they really hated it, but it just seemed like there were a lot of people who didn't really care. So we started to assume that there weren't really anyone using it outside of basically David and I. We changed some things about it, inadvertently broke it, and then we got a bunch of complaints from people who evidently use it. So the lesson, I guess, here was basically that people usually don't say anything when they're happy, or maybe at least content. Just sort of a corollary to the squeaky wheel gets the grease. So basically just, don't assume that just because somebody isn't commenting on this thing that you produce that people aren't using it or are unhappy with it. They might actually be totally happy with it and just don't have anything to complain about. Or maybe they're not 100% happy, but they're happy with it enough that they're not going to complain. So a major topic lately has been the issue of trying to maintain consistency in how we name things. There's a specific discussion that I guess is still sort of ongoing about naming conventions with regards to KUnit tests, and it kind of spilled over into naming conventions for tests in general. And I thought it was interesting because I think it's a place where I probably didn't put enough structure on initially. I started off with some very strong opinions and then very quickly backed off on those opinions. And we ended up with a lot of inconsistency in naming, which evidently there are a number of people who care quite a bit about. There was a discussion. Yeah, Tim just said naming is the biggest way to bike shed ever. So we created a guide, which it's not been. I think it's now accepted as of 5.9, or maybe it hasn't. I can't remember. We did propose a naming guide, and since then we've had 2 independent conversations come up where people didn't like the fact that we were renaming tests. So yeah. I guess that's basically a lesson learned there, is that's something you really, really need to watch out for in the future. I think probably the biggest lesson for me personally has been, I started off having a lot of really strong ideas and beliefs about how KUnit should be, and how we should do unit testing in the Linux kernel. And I've been continually humbled by the fact that I've basically been, I feel as though I'd basically been wrong about most things. Maybe not in like the most general sense, but that was just the goal, I think, is something that's heavily agreed upon. Unit testing is something that should be available for the kernel, and it's important to not let your own opinions about how that should be done get in the way. But I think I also kind of overreacted in the first, like, maybe Q1 and Q2 of this year. I think I kind of backed off too much and sort of was kind of letting other people decide how things should go. So I don't know. I guess that's kind of, and I've heard that's like a really challenging thing to, provide enough structure without being overbearing. So I kind of felt like there was kind of this apt comparison of comparing the Linux kernel hive mind to like a river. It's a good idea to provide structure and facilitate, but you don't want to, it's good to try to like maybe guide it, but you don't want to get in the way of it either. But I think it's more subtle than that. Actually knowing whether you're in the way or not can be pretty difficult. Sasha? I guess that was a mistake.
It was just the 5 minute. So.
Oh, okay, cool. Yeah, I think we're good on time. So plans going forward. Obviously, we want to finish up Kernel CI. We're going to start working on mocking. We're actually going to do it at some soon. I swear it's actually coming. We have someone working on parameterized testing. I know that's nowhere near as big as Kernel CI or mocking, but I wanted to mention it because I feel like all contributions are important. And we have a lot of test conversions coming. It occurred to me earlier on in the presentation, I totally neglected to say, to mention 2 internal features that David and somebody else had contributed. David had contributed to splitting out some of the functionality of KUnit tools, so now you can use it to just parse tap results, which I imagine is something that might end up being useful to people outside of KUnit. We also had a feature that has been in progress for a long way that integrates a number of dynamic analysis tools into KUnit result reporting. So that way you can just run KUnit tests and it'll also tell you whether there were any, like, for example, KA-SAN failures in relation to the test that we're running. So I also wanted to mention there was another thing that since these things are kind of new, I'm only going to talk about the KUnit tool support for QEMU because I don't think I'll have time to talk about the other one, and it's kind of less thought out. I recently proposed an RFC for QEMU support for KUnit tool, and basically I was going around trying to test KUnit and on as many architectures as I could, and I found that trying to come up with minimal kconfigs that work with toolchains and QEMU configs is kind of a pain. So I thought it would be kind of cool thanks for posting that, David. I thought it would be cool to make a script that you could just basically run. You can specify all of your KUnit tests that you want to run, and it'll just run them on any architecture for which there is QEMU support. Anyway, I would kind of like to know what people think about that, whether that's useful or not. I think we're almost out of time, so I think it's probably best to turn this over to questions. So thanks. Here's how you can reach out to KUnit. You can either email KUnitDev, LinuxK self-test, or join the IRC room, KUnit on oftc.net. Thanks, everyone. I think we only have like 1 minute left, but hopefully there's someone who has something they want to comment on. Oh, also, David, yeah, is there anything, if no one else has questions, David, is there anything you feel like that I've missed? Probably unfair to give you less than a minute.
I had a quick question on the separation of the build step and the run step. Right now, KUnit tool kind of combines those together, and I think there was some discussion with Heidi about how to kind of decouple the kind of kernel build from actually running the test. I know they're tightly coupled anyway, but in terms of fitting into CI pipelines, that seems to be a issue.
So that is actually decoupled more in the KUnit tool. Now there is actually a separate KUnit tool build and KUnit tool exec steps, so it is possible to split those out. It hasn't really proved, I think, as useful as we'd hoped thus far, but at this point, yeah, you can split those out. There's also config steps and that for generating configs using KUnit tools excessively fancy config mechanism. So
okay, I'll have a closer look at that then.
Yeah, that wasn't I didn't take advantage of that in the change that I posted to the Kernel CI core repository. But that's partly because taking advantage of that would actually require significantly more changes to Kernel CI. So I was kind of hoping that, which I know I have a bunch of things I still need to do for the Kernel CI stuff, but I was kind of hoping that that was something we could address as follow-ups. So basically the main issue is that Kernel CI doesn't seem to have a mechanism to allow you to run a script to generate a KUnit config, a dot config that isn't tied to make. Is that a fair assessment?
Yeah, that's something we're missing that we would have to look at adding in.
Okay, cool.
But I think we're out of time, so let's take that discussion to the chat. And I'm uploading the next presentation from Luis, and I will make you the presenter. You ready to go, Luis?
Yes, I am.
Okay. Okay, you should have controls now, so it's you.
Great. Well, I'm going to be talking about KDevOps. I am a file system developer at SUSE. I've been working in the kernel for a while now on different components, and lately I've been working on file systems. So let's jump straight to it. KDevOps is a framework to configure, bring up target hosts, and run Linux kernel development workflows using modern DevOps infrastructure. Now I'm going to explain what this all means, and we're going to cover original motivations, what the bring up gap was that I found, command and control and what I mean by that, what we have today with KDevOps, and also what's next. The original motivation really was to reduce the amount of time it takes to stabilize a new file system in Linux. Now, to help with this, I tried to get an idea of what people thought about this. But before we move forward with that, let's get straight a few key concepts so that people who are not familiar with testing, have an idea of what I'm talking about here. Baseline, what is this? So baseline basically just means you have a series of tests, and you have a series of tests that you know that are failing. You don't want to introduce new failures. These are known as regressions. So in terms of file systems, what is a new file system anyway? So Btrfs, is it a new file system? Btrfs has been merged in the kernel now for 13 years. On January 26, 2007, is it a new file system? The answer really depends. If you ask people, you can stabilize a file system in 2 years. This is just general concepts on Twitter, very informal poll, 714 votes. So ask your local file system developer expert. Give or take, people will tell you consistently it takes actually about 10 years to stabilize a file system. So to try to understand why it takes so long, we must divide and conquer. So why does it take so long? And also, does stable really mean that there are no issues found? Part of the problems here also happen to be because there is a lack of documentation or no documentation at all. This is very, very, very prevalent in file system development. It also means that it's going to be very difficult for new file system developers to ramp up. So to test file systems, you have a project called XFS tests, which I'm going to be referring to as FS tests now because it confuses people because they believe that it is very unique only to XFS. It's not. It's used by every file system developer to test their file systems. We have directories for different file systems to run different tests for different file systems, and we also have generic tests. So it has evolved into generic file system framework, test framework that we have in the Linux kernel. Now, testing, what does this look like? We have sections. These sections are marked in green here, which I'm pointing to at now. Default, Btrfs, and XFS. Default are generic shared configuration parameters. You have then your file system specifications. So each of these are sections, okay? So when you specify a section, it'll embrace those parameters that are embraced in them, so you can override other variables in them. So this is what a configuration looks like, just to give you an idea. So OS check was an original motivation that I had, and it basically tries to reduce the amount of time it takes for you to actually run tests with FS tests. And what it consists of is essentially just a wrapper that lets you test things per sections. Now, per sections here means per MKFS params. And what I mean by that is that you can create different file systems with different parameters, and we support different parameters for creating file system. Very simple example is journaling, or another one might be, for instance, now ref links, right? So ref links now are a new thing, right? So in XFS, ref link support was added relatively recently. It's not stable in the 10-year sense, but it's present and is available. I think it's default now in XFS, for instance. So we define different sections for different MKFS params that you use. It also tracks the different expunges for file systems. So expunges here is just a term that FSTest uses for essentially known failures, if you will, essentially tests that you want to not run. Now, you would add a new expunge entry per new failure, and you would ideally want to track these as well. It also installs all the dependencies for you, and what was missing here was bringing up the systems. So this actually should be easy, but it's not today. So that's what I mean by the gap. The bring up gap is what I found in OSCheck to be lacking. And in discussion with announcing OSCheck, Matthew Wilcox had mentioned that his opinion was that we should just merge K-Test with OSCheck. K-Test, for those that are not familiar, is a script that runs in the kernel, lets you run a specific KUnit test with a specific kernel configuration really fast. It's slim, it's nice, but I looked into it and I disagreed. I really didn't like the amount of hacks that were available, and I also really didn't like that we only had one cloud solution. That was Tetso's solution running Google Cloud Compute. I wanted something a bit general. So what do I mean by that exactly? The bring up gap, here I list a few type of hacks that people have put together. Each of these people use. I even had written my own KVM test as well. Everyone in every group seems to have their own bring up scripts. Then you have different operating system preferences. Not all Linux kernel developers are running Linux. I know folks are using OS X. There's folks from Microsoft also working on Linux as well. They don't necessarily run their Linux as their primary operating system. Then you have different virtualization technologies, KVM, VirtualBox, and both of these you can run on Linux, but you can also run VirtualBox, for instance, on OS X. Then you have different cloud solutions, right? So how do we address this? So key concept is, again, here, a command and control design goals. What I mean by this is that when I do bring up, I also want to extend your SSH configuration with the provision nodes that you have created. Typically, you also want to just copy over your git config, your favorite bash scripts, and so forth. You want to install different preferred, workflow type of dependencies for the target workflow that you're working on. For instance, FSTest has a series of dependencies. You also want to install your favorite, package like Vim or Enhanced or whatever. You also want to be able to collect results. So this is what we want a command and control architecture to support. So I split up KDevOps eventually into three major components that you can think of architecturally. One is the bring up part, one is the KDevOps configuration, and one is the workflows. The bring up basically addresses bringing up the target host on local virtualization technologies or cloud solutions. Or you basically skip this and you use existing nodes on bare metal. KDevOps configuration are basically what types of things you want to do, your custom local hacks, and also any other sort of dependencies that you may need. Then you have your target workflows. This is, for instance, what you're going to run. One example might be even KUnit, for instance. But in my case, I'm targeting first the Linux kernel. What I mean by that is that I want to be able to get Linux, compile Linux, install Linux, reboot, and make sure that I'm running Linux. That's a simple workflow that I wanted to target. And there are different workflows that you can add too. So the tools that I ended up using after looking into everything that was available was Vagrant, Terraform, Ansible, and the last and the savior of all this was KConfig. What I mean by KConfig here was I simply embraced how we use the languages for modeling the kernel for configuring your preferences, both bring up your cloud solution and also what you want to do. Ansible here is the component that we're using for command and control. So this is an example of the result of this work. You basically can run a full file system test in 6 commands here, 1, 2, 3, 4, 5, 6. And you basically configure it, you install the dependencies, you do the bring up. This will, after this command, let's say you specified you want to bring up 10 hosts. At the end of this command, those 10 hosts will have the Linux version that you specified with the patch, if you have an extra patch available that's not upstream, merged, compiled, installed, and ready to run. After this command, you'll have FS tests completely installed. For those that are not familiar, that's in var lib tests. Yes, Tim, I'd love it to be in user test or whatever, but I think a symlink would do justice as well and would work as well. If you run this last command, this will actually run the test for you. Now, how do we get results? We just run git diff. Why? Because developers are used to running diff. What does the output look like? Well, since we're tracking regressions, we want to see what tests actually failed. And this is what this looks like. This case, generic 074 is a new failure that I just found out in Debian. It's failing when you're running a series of low amount of CPUs and memory. And this will currently be hosed up with the latest kernel, Linux Next, and basically using NVMe controller. What you actually end up doing. So since we're tracking regressions, you can commit this upstream to KDevOps as well. Since we're tracking this, you can see it's a workflow. It's part of FS test. You have an expunge directory, you have the distribution, you have the version of the distribution, the file system, whether it's assigned or not. And this is basically where we throw all regressions and issues. And you list the actual test that's failing. KORG right here is basically just a reference to a kernel.org Bugzilla entry. Of course, if you're running on a different distribution, you would have your own prefix and bug number. Whether you're running an enterprise Linux as well, we have our own. Red Hat has, SUSE has their own URLs and so forth. And you can obviously fork this project to keep your own regressions as well. So lessons learned. I've seen videos of folks who, at HashiCorp. HashiCorp is the company responsible for Terraform and also Vagrant. And there was a talk by one engineer working on Terraform and also one of the guys working in Ansible, and they kicked it off about talking about how things can evolve and whether or not what should do, provisioning and so forth. I completely disagree with some of the strategies being considered there for the future. I think that Terraform should only stick to mini provisioning. What I mean by this is your shell hacks and base packages, and that's it. And the reason is that you want people to slowly become comfortable running Ansible locally. Now, granted, I have make targets that allow developers not to have to even worry about running Ansible itself. So we hide this from users as well. We want users to be able to easily be able to also just reproduce an issue or ensure that they're not introducing a regression. That's part of the goal, one of the goals here. Post bring up, as I mentioned, you want Ansible to do the rest. KConfig saved the day here in the sense that without KConfig, we would have had to, for instance, fork off this project for different workflows. With KConfig, we basically can now merge different FS tests or different workflows like FS tests into KDevOps. Ansible also has revealed to help slowly parallelize unparallelized frameworks. An example there is FS test is completely not parallelized, and it's starting to push us to think about how we can actually reduce the amount of time it takes to test FS test. See, next slide's not coming up. There we go. So what's next? Integrating a baseline generator. What I mean by this is we want to easily run a series of tests and immediately get the list of known issues. The problem with this, of course, is that if you run into an issue that opposes the kernel, you have to reboot and so forth. We have support for watchdogs and all this stuff, but we just need to script this out to do this automatically. Other workflows that I'm considering adding in the short term, block tests and self-tests. And I intend on enabling this, for instance, self-test to allow to tell developers to easily just go and test test new patches for the components that I have where I have self-test that I maintain. It will also help commoditize how much money you have to spend on testing a full file system testing on the cloud, for instance. Is it cheaper to run tests on the cloud versus local? And yes, containers are coming. I won't get into that because we don't have much time. I want to leave more time for discussions. Questions?
So the first question in the chat was about containers exactly. So maybe you do want to get into that. So why not use
Great.
containers to deliver the user space to the test runner instead of the Ansible?
It's the same reason for why we hesitated for a while to use local loopback devices with testing the file systems. In the end, we decided to embrace loopback because we'd essentially have more issues rather than less issues. Yes, we do want to use containers. However, that'll introduce more issues rather than less issues, and it will basically blow up the kernel right away. Yes, we want that, but not right away. So the answer is yes, we want to do that, and yes, that'll solve the issue. You also need to consider that per test, you also have to consider amount of resources that are going to be increasing per test. So we're talking about, consider 600, 800 tests. Can you run, how many containers are you going to run to dispatch tests? So yes, we want to do that. That'll be next. Other questions? Can this work with NFS? Yes, it can work with NFS. And in fact, at least Vagrant has default support for NFS, and you can also use Plan 9 and so forth. But the question really should be, if you think about it, how do we address a shared file system support for not only something that uses Vagrant, which is localized, which I'm using for localized VMs, but also on the cloud? So we need to consider how do we address this architecturally for bring up for all these solutions. And yes, we can certainly go with NFS. I think we also need to come up with a generic solution. I think Plan 9 might actually be better here. But again, patch is welcome, and please test and see what you come up with. Other questions? KUnit configs. I see there was a question. Yes, I'm actually running. There's one kernel configuration for Linux Next that works on all the different cloud solutions, Azure, AWS, and so forth, and also local KVM and VirtualBox. So that's present. That's tracked in an Ansible role and a boot Linux role. So boot Linux is an Ansible role that basically gets you Linux running. It's a workflow as well, but if you think about it, you may want to target different kernels for a FS test. So you use the boot Linux role as well to run a FS test as well. Another question from Dan Rue is, when running in the cloud, are you still running example Vagrant? No, we're not running Vagrant. When we're running in the cloud, we're simply running Terraform directly. The only thing that we're going to do locally is to modify your SSH configuration, because Terraform doesn't do that, and updates your SSH configuration with your target nodes. So that way after this step, then you can just run a new make target, and then you can SSH and run into those hosts. You can also run a random SSH, pub key and so forth. And by the way, I did randomize the keys. There's security implication as to why I did this, but essentially, you always generate a new SSH key for each target host. Other questions? All right, thank you.
Thank you, Luis.
Thanks.
We're now going to switch to another quick break. We'll reconvene back again in about 15 minutes. Feel free to continue the chat with Luis and continue the conversation. See you back in a bit. Okay, we're almost ready to get started again here. Just a couple more seconds. Okay, Guillaume, you should now be the presenter, so you can take it from here.
Okay,
Thanks.
can you hear me?
I can hear you.
Perfect. Hi everyone, we're here to talk about Kernel CI as a growing ecosystem. So let's take a step back first. You know, the Linux kernel, as Linus Torvalds said in an interview in 2017, is a social project. Now, what does that mean? Is the success of the Linux kernel is based on the ability of hundreds and thousands of people to collaborate and work together to produce one thing that works for all of them. Now, following this trend, the Kernel CI project is also there for the community, and its success will need also to have to benefit from this, to be made by the people, by the kernel community. So what is the ecosystem? What do I mean by ecosystem here? We have, of course, the Kernel CI team, which I'm part of, and Kevin as well, and many other people. That's not very precisely defined. It's basically everybody who contributes directly to Kernel CI itself. Then you have the Linux Foundation project members, our sponsors, if you want, for the project. And then, of course, you have the kernel developers, maintainers, and developers. And then, of course, you have all the kernel ecosystem you have around, like distributions who make operating systems. You have OEMs, people who make products and ship the kernel, and SoC vendors. And then, of course, when you talk about testing, you have people who write the tests, things like, KCL test and LTP, people who write that. You have people who make test systems, so either it's like a test lab or a complete CI system like CKI or 0-day. Cloud providers, I mentioned it here because it's very important for Kernel CI, since we're using cloud VMs donated by Microsoft Azure and Google Cloud to build kernels and test things. So all these different players play a role in the kernel ecosystem, but also in the kernel testing ecosystem, and all play a different role. Now, I think the purpose of this talk is for you to realize, that you're part of that, maybe part of different bits, and Kernel CI is there for you. So the team, the Kernel CI team, is here to facilitate things so they can happen in the way that it works for you. So if we go to the next slide, this is of course, the purpose from a functional point of view is to have a testing loop. So you have the contributors contribute to many things. Some people contribute to tests, others to kernel code, which gets built, and then the tests get run. And then you have results sent back to contributors. Now, I think everybody knows about that, but I thought it would be useful to bring it up as a simple picture so we can see how all the different players and how the different parts of the ecosystem work together. So to summarize the main message here, so in the same way that we have one Linux kernel, the purpose of Kernel CI is to have one main CI system. So it's not designed for any particular product. You have loads of people are testing the kernel for their own products, for their own distributions, like I explained before. So Kernel CI is about testing the kernel for what it is. So one of the principles behind it is what other people have started calling as well the open testing philosophy, where you can share your hardware. So you can have your test run on someone else's hardware or someone else's test run on your hardware. And so you don't just run things in your own silo. We can group results as well. So if you do run things separately, we can still compare the results for the same kernel revision. And also it has to be driven by the community. So the key decisions, or actually the energy that's been put into it, so why new things are added to Kernel CI, that's driven by the community and not by a particular vertical use case. So how do we do this? Well, in many ways, being inclusive, and we have meetings that are open every week and all that. But also, we've made a survey in June and the results have been compiled into a report in July. There's a link at the bottom here. I've just copied some graphs as illustrative purpose. But three main things came out of it. So Kernel CI needs to test patches more, and that means testing patches sent to the mailing lists before they get applied to any Git branch, because right now it's only monitoring Git branches. That means we can send results earlier to developers, and then people would buy in more into test-driven workflow. With short tests, of course. The second point is having longer tests and deeper tests. That makes more sense on maybe mainline, on Linux Next, or stable, and that's also very useful to try to validate a kernel in a way. And that can only be done by having everybody contributing their results together. And something that came up as well is that we need to improve the web dashboard. I know a lot of people really care about emails. That's something we definitely need to keep doing. But it's also worth mentioning here that web dashboard is something a lot of people care about, and we don't have a very good one right now. It's a really hard problem to solve. So if someone has some ideas, it would be great to have. It's something we don't really know how to solve right now. It's something we'll be working on in slightly longer term, I think. But the key thing is it needs to be flexible enough so that people can configure the view that they want. Like, some people care about one platform, some people care about one driver, some people care about one type of tests. And it's really hard to have something that's flexible enough for all that. Anyway, so that was a quick summary. We can discuss more details about that, and feel free to read the full report. Now here's, on this slide, I'm trying to give examples of how the ecosystem around Kernel CI is actually growing in practice. And what you'll notice here is that all the players I talked about with the picture about the ecosystem, I think all of them are represented here. Maybe not the OEMs too much. But you have, Lava Labs, we have more and more of them. CIP just added their lab. We've added, test bisection, that's more to send targeted email reports to people who broke something allegedly broke something with our patch. Kubernetes, that's the cloud infrastructure. We use that to build kernels. And then, Kernel CI is available as a Python package in PyPy now to have the core tool, so you can reproduce Kernel CI builds and run tests yourself. So everything under that timeline is what's already in production and things that have happened in the past year or so. But also there's a lot of things ongoing. So KCIDB, which is, the next talk is going to be about that, so I'm not going to spend too much time on it, but it's about gathering test results. So Red Hat played a big role in pushing for that. We also have KUnit, and that's being developed directly with Brendan Higgins. He made a pull request to start adding that in Kernel CI. Self-test, we're working with Shua, and there's, I think, a Linux kernel mentorship program to have that added in Kernel CI. We're starting to add LTP as well. So these are the tests. We also work with other CI systems. So we started talking with Dimitri from Google Sysbot, and also Philip Lee for 0 Day, to try to gather their results and compare results between, for a given revision, you have different people running different tests. And what's a really good example is that since the beginning of this week, that's something I had to add on top of my existing slide. During LPC, there was, in a real-time microconference, when people started talking about testing, and what came out of it is that it can be added to Kernel CI. So other systems like CKI already, I think, do some real-time testing, and we can get their results. But also it's useful to add it as a native test in kernelci.org. And since the beginning of this week, it's only Wednesday, but now we've actually started running tests, and we're seeing some results on the staging.kernelci website. I have actually a link here. It's all really fresh stuff. And it's not perfect. There's still a few issues with that, but that's the kind of community-driven thing. You talk to real-time people, and then you came up, people work together, and then this happens. Then, like I said before, this is something that is Kernel CI is there for the community to be driven by the community. So here I have a quick poll to see what, out of these three things, have an idea of what you would, well, if there was one thing that you would like Kernel CI to be working on next, or if you wanted something like next week or next month or something, what is the most important thing you would like? About item C, what I mean by that is when Kernel CI sends you a report with an error, it's about having the ability to fix it. So if you don't have the platform on which the error happened, how do you inject your patch to try to test a fix, or how do you enable a debug config? Just to clarify item C. So while this one is really, I think, is useful here, but also what's important to keep in mind is you can keep asking yourself these kind of questions every day, and then if you think, I wish Kernel CI did that for me, then you can reach out and either do it yourself, but if you explain what you need, we have some people who work on that full time and can help integrating, adding your changes, just in the same way that we've done with all the other things I've mentioned. So so this is basically the end of my slides. But here, if you have things in your mind, I think there's a lot of things that have been mentioned during this micro conference already. Sorry, I forgot to publish the polling results. Kernel CI keeps coming up in this conference, which I suppose is expected. Okay, so yeah, sending patches, that I think lines up with the results from the surveys. And yeah, thanks, that's interesting. So again, if you think of what's burning, what is the thing that you would really like Kernel CI to do right now? Or if you have questions about all the things we have just talked about, feel free to ask now. I think we have like 3 minutes. Yeah, of course we want all of them. If there was one to pick, which one would that be? Yeah, thanks, Daniel Wagner. Yeah. How easy these days for Lava Worker to contribute spare cycles? Oh yeah, okay. So there are things you can do about that, because you can define, for example, which tests you want to run. So you don't have to run all the available tests in your Lava lab. You don't have to run tests on all the trees. You can already narrow things down this way. You can also use priorities. So you can run your own jobs at a higher priority. So even though the queue might, some things might pile up a bit in the queue, if you want your test to be run first, you can just run them with a higher priority. If some tests never run, normally Kernel CI won't stop for that, because it's kind of asynchronous system. Like the kernel development will carry on anyway, regardless of Kernel CI results. Maybe in the future, people will be waiting for results from Kernel CI before like releasing a stable tree or stable version or something, stable tag. But right now it's not like that. So if your lab is flooded, well, first thing is you can tweak the Kernel CI configuration so that your lab does not get flooded. But if that does happen, you can cancel jobs and nobody should be hurt by that. Now we have another question. If a test failed to start, is there any automatic retry mechanism to retrigger the run? Not really. However, we can detect when it's an infrastructure error if the lab says that test failed to start due to the power on command didn't work, or the bootloader didn't work, or the HTTP didn't work. So, but there's no retry right now. What typically happens is because we're testing the branches continuously. It depends on the branch, of course, but some branches will, they'll get another push, and then the next version will be tested. If it's something that's really important, then it's possible to manually rerun a test. But I mean, retrying, it's an open-ended thing. How many times do you retry? And it's not something we've struggled too much with. Normally, if there's infrastructure errors, the people in charge of the infrastructure will fix it, and then that's the best way to solve it, basically. Maybe one more question, and then we go to the next talk. I see Mark is typing. Right. Okay, cool. So I'll carry on talking for a few slides, but this talk now about unifying test reporting with Kernel CI is shared with Nikolai. Here we go. I'll wait for Nikolai to be ready. Hello.
Hi, everybody.
Cool.
Take it away.
All right.
I'm Nikolai Kondrashov. I'm a software engineer at Red Hat CKI project.
And I'm Guillaume Tucker. So I'm senior software engineer at Collabora and also chair of the technical steering committee at Kernel CI. And if you haven't noticed, there's a small icon. Actually, it's not working. Kevin, can you please hit download option? Normally, you should be able to download the slides with that.
Yeah, it's there.
Here we go.
For us.
All right. Now, if you click on the arrow, we get the slides. So I'll start with a quick intro. So the testing landscape. So that kind of relates to the previous talk, but here we go into more specific topic. So who tests the kernel? You have individual contributors who test on the hardware they have, and maintainers who test on the platforms they have and whatever local CI system they've made. You have distributors, distros, distributions, and product manufacturers who test on their own platforms. And then we have projects. So all this is very useful, but people do it because they have a vertical use case in mind. Then you have some wider testing systems like 0-day, although that mostly runs on Intel x86. And then you have syscaller, like Dimitri talked about a bit earlier, which is great. It does fuzzing, which doesn't really replace functional testing. So all these things are complementary to each other. So here we go again with the open testing philosophy. So the test systems are stronger together. So that's really the background of what we're just about to talk about. I hand over to Nikolai.
Yeah, I'm waiting for my presenter rights. All right. Thank you. So as you know, there's multiple systems which test the Linux kernel, and each of them has their own dashboard, and each of them sends their own reports to developers, which is of course suboptimal because, well, developers have a lot of email essays and they get all these kind of different emails from all those systems, and they have to know how to deal with each of them, and then of course deal with each of the dashboards in different ways how to do that. And then of course the developers of those systems have to duplicate the work. So last year after Plumbers, we got together at the CKI Hackfest, a bunch of people from various companies, and we talked about trying to pull in the effort and cooperate and save us the trouble of maintaining all these separate systems, and of course save the trouble to developers who have to read all this email. But at some point we decided that we could start joining the efforts at the stage of reporting where it's easier to agree on and provide a place and ask around and get something standardized with regards to reporting, so that we can send a single email and have a single dashboard and save everybody's time. And if that works, perhaps we can move on to back in the pipeline and standardize other things. That's what we wanted to start. So a few of us got together right there at the conference and started throwing together code, and we started this thing called KCIDB, which tries to solve this problem. And KCIDB is a part of our Kernel CI project.
Okay, so on this, I don't have presenter rights, but I can still start talking. So on this picture, you can see how we have the Kernel CI parts that have been there for a long time. So you have Lava Labs, and now we're starting to run static checks like device tree validation and maybe KUnit in virtual machines. Also, we have people who have custom labs that are not Lava, and all these results. All these tests are running what we call native tests. So the things you see currently on kernelci.org, and that's being sent to the Kernel CI backend database. What KCIDB does is pull in other results from other systems. So right now only CKI is actually being connected, but we're talking to 0day and Syspot and maybe LKFT, and you can contribute yourself as well if you have your own system. So that's another way of gathering the results. We also have a tool, work in progress tool called KCI Data. That's to make the link between these two databases, so you can have the native results being sent also to KCIDB and to provide an abstraction interface. So you can see there's now like kind of 3 ways to submit results to Kernel CI. You have the Lava Labs that use a callback to automatically send results to the backend. You have a generic API, which anybody can use, and that's basically used for non-Lava Labs or static analysis. That's also being to send the results to the same backend. So any results sent to that will also appear on the current front end. And then the third option is KCIDB for anything else if you want. This is what the rest of this talk is about.
So this is the specific architecture is very simple. So each of the submitting system sends their test results after they are done. Well, each of the artifacts is done via a single endpoint in JSON format that gets put into the database, and then you can have a dashboard to look at that database. And there is also a subscription system which watches what's already in the database, what just arrived, and then sends notifications with reports to developers. We have command line tools, we have Python library, we have a prototype dashboard built on Grafana. We have an alternative dashboard being worked on by CKI project. It's a work in progress. We have all the links at the bottom of the slide, so if you want to take a look live at those dashboards and whatever is linked there. Finally, we have proof of concept reports sent on internal development list. Well, we can access it, but it's just that people don't get those reports yet. So, designing the schema, we wanted to keep it as simple as possible and as easy to extend as possible. So, at the top level, there are 3 arrays at the moment. Each of these could be either empty or missing. One of them contains revision objects, build, another one builds, and the third one tests. But you don't have to send them all at once, even if they are linked. You can send them in pieces as you execute, as you complete your results. You can start with a revision in the build being sent, and start another revision and send build for it, and at the same time send in test for something else, and then later send the rest of the tests. All the objects are linked using IDs as you would in the database. The revision ID is standardized, but the rest of the IDs is up to the submitter. And the submitter is responsible for making sure they are unique. Another important field is where the report object is coming from. And each submitter has their own name to put there. And this actually concludes all the required fields. You don't have to put anything else to qualify to the schema, to match the schema. So this lets you start your involvement earlier and ramp up the results by adding some fields first, which make most sense, and then add some more, and then add some more as you go along. So this lets you grow your involvement gradually and get results sooner and get started iterating on your involvement much sooner. I also have special builds called MISC in every object. They will take any JSON, and you can put there some data that you would like the formal schema to accommodate, but we don't provide for that yet. So this way, first, you can get that data to developers, and second, we will have some samples to decide how to accommodate it in the schema. You can also use that, for example, for debugging, for linking objects in your testing system to the reports. We have started talking to Sysbot, as Guillaume probably mentioned. And Sysbot, as you probably know, has a very nice feature of tracking issues and assigning test results to specific issues so that developers are not bothered by the same issue being reported again and again, which is very important for them because they run a lot of tests. So to accommodate that, we plan to add an issue object and an incident object, which would link the issue to the test. We're also thinking about linking those to build issues as well. We are also talking to Zero Day, and they have some static checks running, and we cannot accommodate them, but not in a very nice way. So we're thinking about adding a check object, which would represent those results. Another Zero-Day feature is that they send log snippets and not links to logs hosted somewhere else as we do. So we'll need to accommodate them by, for example, adding fields that store the snippets directly in the JSON report. Otherwise, please take a look at the JSON schema and available at the link here.
Thanks. So the next section is it's called From Dashboard to Dashboard, but that really is to show how we can have results from separate systems being pulled into one. So there's a lot of details on the slides. I'll be going quite quickly. You can look at them in your own time if you want to look at more things. So first of all, there's the revision. If you remember what Nikolai just explained, we have revisions and builds and tests. So a revision is really a commit from mainline, for example. That gets detected. Well, at first, you can see a representation of that on kernelci.org. So you have the revision and some results associated with it. This is the counterpart version from CKI, which I don't think is public, but there's Veronica has just put a link that it's becoming public. So you have these two systems have seen the same revision. Here is a piece of JSON that was sent by CKI. You can see an origin being Red Hat to KCIDB. So now we have three systems. You have CKI, Kernel CI, and KCIDB receiving results from both Red Hat here. So Red Hat is CKI, and Kernel CI, which is the native tests. You can see there's that's the URL and the same kernel name is here. And then for this revision, you have some builds here. Now you can see, excuse me, this is on kernelci.org, a representation of a kernel build, and that's the JSON that needs to be sent to KCIDB to describe that build. And then for a build, that's the version of, the view of that build from KCIDB, which has the same metadata, but you can see the tests that have been run for that build here. That's from Kernel CI, the native one. And then you have, so that's one test case. So in the previous view, you could see like the summaries, but you can also send one test case, and that's the JSON needed to send one test case. And then you can see the detail of that test case appearing here as well, so on that common dashboard. And in the same way that you have builds and revisions, the test also can be coming from CKI. So here it was run on a VM, it's a boot test, so similar to the login test we had from Kernel CI. So CKI sends a JSON, and that appears also on the Grafana on that dashboard. So you can't see both results together, but you can on the same view, but they are visible, all of them on the Grafana front end if you search around. So that's really to show how multiple things can be pulled together. Then the next step is about how to correlate results together to see that results are for the same revision or the same test, and this is what the next section is about, correlation.
The correlation is a work in progress, and so you already seen that we standardized revision IDs, and you accept the basic commit hash for a committed revision. You can have another ID for a revision that is patches on top of some other committed revision, and it's encoded as commit hash plus character and patch set hash, something like this. And the hash is very simple to calculate. There's the examples in Shell and Python. It's simple, but it's easier to understand, and it's good enough for these purposes, I think. Next point is correlating tests. Actually, calling tests the same name everywhere. So for that, we have a test catalog. We're still working on actually taking use of it, but we have standardized some of the test suite names. And here you have a description for KSelf-test, and there's the name that we chose to represent it by. We use that to put it into the test JSON and put it into path field, and it will appear in the dashboard. And if in this case, like this, the whole KSelf-test suite is represented by a single object. But if you want to go in further in details and report all the different test cases that KSelf-test has, you can also do that by putting something like this in the path, and the system is supposed to summarize those results at any level so that you are able to compare results between a system that sends all the details and the system like CKI, which sends one result per test suite. Another thing that we need to work on is environments, and basically hosts where tests execute. So right now we are just adding the human readable description of that environment plus the usual MISC field, and this is how Kernel CI reports that, and we can use that data to expand the schema to accommodate it later. But right now there's no correlation, and that's what we're gonna work on soon. So we need to first, of course, identify the exact environment so that we can group tests by host in the reports and the dashboard. And then we might need to have, it would be very nice to have a way to compare environments, how similar they are, so that you can, for example, compare tests running on the different revisions of the same board or the same architecture or whatever level you need. So there are some ideas that we have, but that needs thinking through, and perhaps somebody from the audience have some ideas. I don't know, would be good. So since we already send a lot of tests, and as people join, we will send a lot of tests to the system. It would be quite impossible for developers to withstand that kind of traffic of test results. So we are putting developers in control, and it's up to developers to what to subscribe to. They want to see some results, they can subscribe to them. For example, you can have a subscription, let's say, asking for block test results for SCSI tree, for master branch, sent to Linux SCSI mail list, and another one asking for all stable repositories being tested and their results being sent to the stable mail list. In practice, a subscription is basically a small Python module which gets access to all the properties of those objects that come in from the database, and can pick and choose what they want to match, what's important for them. This is, of course, not very performant and might be difficult to navigate, but this is the start. We are trying to find out what developers need, what we can do, and once we figure most of that out, we can transition to a more special system which will be more performant and easier to understand. So here's how the proof of concept report could look. It's not pretty, but we are just trying to find out what we can get, and how do we have all the data that we need to produce a meaningful report. And here's one. So there's the summary, of course, of the revision, and then we have a list of builds, and we can have a Kernel CI builds there together with CKI builds. We can have test summary for Kernel CI and then test summary for CKI in the same email. The submission interface, well, we try to keep that as simple as possible as well. Here is how sending an empty report would look in Bash and how it would look in Python. And here's another example, the complete Kernel CI backend module, which translates the Kernel CI data to KCIDB. It comes up at 257 lines of Python using Kernel CI submit command line tool. So we'll have a Birds of a Feather session tomorrow. So come in, and we will walk you through how submissions work, and we'll discuss schema details, and you can just chat about this, and would be happy to see anyone who wants to send their results, and also developers who want to subscribe or just give their feedback and requests what they want to see. Otherwise, during the whole conference, we are on the KCIDB channel. And finally, the GitHub repo for the KCIDB project is up here. You can find us on Kernel CI email list on groups.io, and also on Kernel CI channel on freenode.net. Thank you. Questions?
So yesterday in the kernel dependability microconf, there was some discussion around static analysis and stuff. And one of the speakers, Lucas, actually specifically brought up this idea of how to collect results, a common place for collecting results for static analysis checkers. So I don't know if you were there. I think Guillaume, you were there. But I wonder if you guys have thought about that at all for more static analysis type things that are not runtime tests.
Yeah, this is what we are trying to do for 0 day, I think, and that could accommodate data. And in general, I think that having a common database would help greatly with analyzing past testing results and correlating them.
It's also possible to use the generic API, like I've explained. Now, this hasn't been used too much because we haven't been doing static analysis too much, but it's almost fixed. It's almost ready for that now to send results that don't depend on a build, but just depend on a revision. And we'll be enabling this with device tree validation first and KUnit as well. So that's why, that's not sent to KCIDB directly, but all the data sent to the native system, Kernel CI system, will be shared with KCIDB as well. So that's another way of getting things integrated.
Shoa, you have a question?
Yes. In terms of, if you have given it static analysis some thought, what tools are you looking at? Are you trying to match what 0 day is doing, or any more information on that, on which tools that you're considering?
Well, within the KCIDB project, we are not doing any tools. The focus of the project is that just to accommodate the data. So whatever is makes sense, we want to accommodate that.
I see. So you're compiling the list of things, not necessarily actually planning to run them on Kernel CI. Okay.
I don't know regarding the natively running those static analysis. Guillaume would say better, but the KCIDB target is to just get the data together, provide the schema which can accommodate that data. Whoever wants to participate in kernel testing is welcome to come, and we'll work with them to make their data fit so that we can archive it, we can present it, we can send it to developers.
Yeah, sure. What you said, it said KCIDB is not running things in kernel CI, it's the other way around. So like the native kernel CI tests results get shared into KCIDB with other systems.
Right. My question is specific to actually kernel CI. And if you are considering adding static analysis, there is two aspects: is running and then providing results. I think you talked about maybe adding static analysis, Kim. So I was wondering if you can elaborate on if you are considering any tools and which ones.
Okay, well, first of all, we want to run them in cloud VMs because we have the infrastructure for that now. Because static analysis normally by definition is hardware agnostic, so we can, we don't need to run that on hardware, on real targets. We want to start with KUnit. There's some, because the work has started for that, although of course it builds a kernel, but I want to say it's an implementation detail. Well, something that's clearly static analysis, or more like static analysis, is device tree validation with a new YAML-based format for device tree. Then of course we could do other things after that. Once we have this infrastructure in place, we can add more more cases.
Right, you'd be running during build though. When you're running build, it would be a build environment, right? Static analysis. So as you're building targets, you could add that if to your build bots, if you have those.
Yes, but I mean, doing device tree validation, you wouldn't do that for every build. You do it for each revision you've tested. Yes.
I mean, I'm talking about kernel as a whole, not necessarily just device tool. But I think that we can discuss that offline. And
if it's about the source code, it's, if you're running a lint or something, it's separate from the architecture you want to use separately on something else, or
I'm more talking about sparse, smatch, like 0-day does. Is that the plan that you're alluding to?
Well, we don't have a plan right now further than what I've just said. So device tree validation, KUnit, we can, but then once we have the infrastructure in place for running things in Kubernetes and having the results that don't rely on the build, because that's something that's always been required until now, then we can add more easily. And that's where having the ecosystem drive, like I tried to explain in my previous talk, that's where it matters. So if people come with, if we provide a way for people to add tests, so either submit their results if they run the test directly themselves, submit the results via KCIDB, like Nikolai explained. We're trying to also be able to have that generic schema accommodated, so it can also include static analysis. Either do it that way or run it as a what I call native test in Kernel CI. It will be managed by the main Kernel CI stuff. So wish lists are welcome. So if you have things you want to run and you know how to do that, that's perfect. I think Tim might have a question.
Yeah, so I've been making jokes in the chat about getting my Fuego client done, but seriously, I guess, what is the rationale? One of the things that Fuego does is test not top a tree. So I'm wondering, is it valuable to get results that are not at top of tree? Fuego is used for a lot of product testing rather than, so we're not in the kernel CI loop for like main development. We're in the CI loop for product testing. So is there any, so like for instance, one of the products I'm working on now is on a 3.18 kernel. I'm pretty sure no one cares whether Sony's 3.18 kernel passes LTP, but is there a value for me to submit results anyway, just in terms of fleshing out the
Absolutely. Absolutely. So as long as the code you're testing is public, submit your results. It's up to developers whether they want them or not. It's they are controlling the subscription, and you can work with developers to promote your results if you want to have your results to have an effect. But we'll take your data and we'll work with you to accommodate it. And actually, I want to invite anyone who's listening, no matter how big your test system or how small, to come and work with us on getting your results accommodated, because that's the whole point of the project, is to get as many results as possible and produce as little email as possible.
Okay, thanks.
I guess that's a nuance with the native tests, like the trees that are currently monitored on KernelCI.org, that these trees always upstream oriented. With KCIDB, like Nikolai is saying, I guess you can be a bit more relaxed with where the data is coming from. And 3.18 is actually also tested right now on KernelCI.org. It's the Android preview 3.18 branch. There's like a super long terms table branch, so it's useful to have 3.18 results to compare with the real products.
Can you guys throw up the BOF slide as we finish up and transition?
Yeah.
I think we have 1 minute left. I haven't seen the warning. All right.
Any more questions?
Yeah, we have 1 more minute for questions if anybody has any.
I think most of the speakers have received a speaker kit with a Lafrit board. I guess it would be fun to have that in Kernel CI and everybody would be running tests on it.
It's already in Kernel CI.
Okay, fine. I looked the other day, I didn't see it. That's cool.
Yeah, I can show my own.
1 minute warning.
Oh, it's actually time's up.
Time's up now.
Okay, thanks everyone.
Okay, our next speaker is Don Zickus from Red Hat, and presentation should be queued up here. I will give Don the presenter rights. So I find it. Okay, Don, you have the power. Not hearing you, but seeing you, but not hearing you.
It looks like it might be your hardware microphone, Don, that's muted. You'll find it. We can all appreciate your beard in the meantime while you're figuring that out. Okay. Hopefully you won't have any issues reconnecting, and Don will be able to join back in just a second.
Yeah. In the meantime, if anybody has any other comments or thoughts on the Kernel CI stuff, please feel free to.
All right, can you hear me now?
We can hear you now, Don.
We can hear you.
Awesome. Let's see if the webcam works. There we go. Wonderful. All right. Hello. My name is Don Zickus. I'm, a kernel workflow lead at Red Hat. I'm also a board member for the Linux Foundation's Kernel CI project. I'm going to try to host an interactive session today about how we can develop metrics to measure testing progress on the Linux kernel. I just have a few slides to kind of define the problem and kind of frame how I want to focus things today, and then we can discuss. It should only take me a few minutes, so while I'm talking, feel free to start poking some ideas about some metrics we can do to kind of measure testing progress into the public chat, and we'll take it from there. So where's my next slide? There we go. So here is the Kernel CI project's mission, ensuring the quality, stability, and long-term maintenance of the Linux kernel. Most people are on board with this mission. They think it's a great mission, and we're trying to find ways to achieve it. So, and a lot of people in the community have been kind of working and helping out and trying to work towards this goal for a long time. So, one of the other objectives of this Kernel CI project is to try to help and corral the kernel testing community and try to organize the community's efforts in order to make this, kind of a successful project here. So we have today, these are our contributors today. Most people are familiar with this. The last 3 or 4 presentations have already talked about this, and we have, community's been contributing for decades. We have distros been contributing testings. We got, CI services like Zero Day and Syscaller and kernelci.org and CKI, and everyone contributes, we provide their feedback through mail lists and Bugzillas. Nothing new here. So all these contributions, things should be getting stable, right? Well, I guess it depends. So a lot of people are doing a lot of testing and contributing to feedback on the kernel, but what are they really testing? Is there a lot of overlap? Is everyone running LTP on x86-64? Are we getting the hardware coverage we need, and LTP is constantly growing? Are we actually making progress? How do we figure this all out? Like this diagram here I have kind of has what I envision of, here's our ecosystem, our testing coverage, and what everyone's contributing and where all the gaps are. But I may be right, I may be wrong, I don't know. But how do we know? So one of the first ideas was to kind of say, okay, how do we, when we put this project together, like how do we start aggregating all this data? Like we have all these people doing all this testing and everything. How do we figure out where we are? So the first idea was to kind of come up with a common reporting scheme, and that's where the KCIDB came along, and Nikolai and Guillaume just talked about it just moments ago. So obviously the idea is to try to convince all these services and people to kind of contribute a copy of their data to the service so it can be aggregated and analyzed by various people to start understanding what's going on with the testing effort here. Are we making progress? Are we anything productive is coming out here? Do we have the coverage we need? So and once we pull all that test data together, we can start making progress. So can we measure testing progress? So we have a way to aggregate the test data. We have a steady pool of testers and services. We even have focused test suites like LTP and K-self-tests. How do we turn this into something to measure, that we can measure to see if the Kernel CI project is achieving its mission? So today, the discussions I want to get to is I want to come to an effect. The effect I'm kind of looking forward to, hoping to achieve, is can we get find as a community to figure out 2 or 3 measurements that we can put on to the Kernel CI org webpage that we kind of track, kernel testing progress is growing, something we can kind of rally around and focus the community on to kind of say, if we focus on these pieces right here, we can grow this particular part of the testing puzzle and make good progress. Something that's very obvious. Now, obviously, software is always going to have bugs. The kernel is always never going to be quite stable at the release, but we should be able to have a steady march towards something we all can feel like we accomplished and feel like it's growing. I listed out some ideas here. The board members of the Kernel CI project always talk about Linux stable and the volume of patches that are being added to it, and one of our goals is to kind of reduce that volume by trying to stabilize things before the kernel is released. So there's an effect there too. So these are some of the ideas and thoughts we're having here about how to make this a successful effort and kind of fulfill our mission a little bit. And even I'll throw out K-self-test. Showa was talking about some of the gaps she has, and maybe we can fill in some gaps there that kind of help drive K-self-test forward, which helps drive a lot of the kernel testing efforts on top of some of the ideas I threw out here. So this is kind of what I had to say to kind of frame everything and the problem and what I'm looking to achieve. So I am hoping there's a lot of ideas and thoughts in the discussion in the chat. I'm not seeing too much, but I'm opening up for discussions. Any thoughts? I'm looking at the chat here. A lot of comments. Yes, I have a nice big beard. Stables aggressively looking for patches to pull in. Configuration coverage. We can do configuration coverage if that's important. I don't know how to define that. If somebody has a way of defining configuration coverage and how we can consistently achieve that effect. Hi, Tim.
So hey, I'm Tim. I work for Intel, mostly on the Yocto project. I'm the Yocto project architect, but we spent about a year trying to do a dashboard to aggregate data and synthesize it and everything like that. And so, what most people are focused on is what are the test cases, or what's the code we're testing, what's the infrastructure, right? The problem actually comes down to how is it displayed, right? So how do you actually synthesize all that aggregated data into something that's usable? And this is where, this is what I was chatting about in the comments, right? It's we need data scientists, big data people, and then we also need really highly skilled modern web devs, right? I did web dev in, 20 years ago. That's when I last got paid to do it. So my skills now are like archaic, right? And we've got tons and tons of fantastic people in the FOSS community that have all these other skill sets that aren't kernel developers, yada, yada, yada. And that's my call to arms. Like, I don't know how to find the people, but the real problems to solve are, what do we do with all this data, right? So Yocto project, as an example, we have 2 million test cases that are run every day. What do you do with all that data?
Well, question is, how do you know you're having an effect? I mean, so I agree with a lot of what you said, and I'm not sure how to apply the web devs correctly, other than just to kind of display the data in a digestible format. And people always talk about AI and applying AI and data scientists to data. But as a developer, I guess in my head, I constantly contribute to Python projects, and they got a whole big test framework and some coverage tools, and they're always trying to make that better. But how do you you have a developer and you're writing tests. A common problem I see at Red Hat is we ask people to write tests to add, expand kernel coverage, but people don't know where the gaps are on the test. They just start writing tests and, okay, here's a bug. Okay, let me write a test case to cover that particular bug, but it doesn't really get us anywhere. It grows the test suite over time, but it's a reactive thing as opposed to a proactive thing. I'm hoping we can generate some discussion about how to be, I guess, a bit more proactive in writing test cases and in growing and measuring stability. Hi, Mark.
So it isn't part of that about, you're saying it's kind of reactive to look at the just writing a test case for when you find an issue and fix it. But isn't that not also a good indication that we're, if something is constantly having, if we're constantly finding that there's bugs in a particular area of the kernel, isn't that a good indication that that's where it's, or one of the places where it's valuable to focus our development effort on? So perhaps it's a bit short-sighted to just write a test case for that individual bug, but it's not necessarily a bad way to look for places where we should be adding more testing. If something is showing up routinely as being unstable and routinely needing things fixing in it.
Agree, but would you also agree that by being reactive like that, you see, okay, this stable system is having a lot of bugs, we can flip that around and start to be proactive in that subsystem for exactly the reasons you said. It's like, wow, this has a lot of bugs. Okay, what's
that's kind of what I'm saying. But what I'm saying is that it's reactive when you just write a test case for the individual bug that you've just fixed. But it turns more proactive when you say, hang on, there's a lot of problems here. Maybe we should go actively looking there.
Sure.
It's taken the same. The initial idea is good. It's just not taken far enough.
So should we start aggregating data about where the problem subsystems are and try to do a call to arms about a community saying, okay, we get a file system and these particular drivers are subsystems? Is that what you're suggesting?
That sort of thing, yeah.
That works for me. I just need to. What would your idea be about aggregating problematic subsystems? Where would we get that type of input data? CI services or trolling Bugzillas? Anyone have an idea about that? Well, it's something to think about. I'll ask Showa. Looks like she has a question or some thoughts here.
Yeah, just a thought on follow on proactively looking for areas, and two questions. Where do we, first of all, we have to look if there is an existing test, and where do you look for an existing test, and where do you add it? So those are the kinds of thoughts. And then also, Mark has a good point. We do want to write tests more proactively and then look for areas where problem areas. I guess that's another thing, right? Where do we look for? Maybe tapping into some of the bug reports that are coming out from the Autobots that might be one area to look for and see if there is one to target. And I know for sure, in K-self-test for sure, we don't have enough tests specifically for a lot of the drivers for sure. And it could be chicken and egg thing. We don't have the infrastructure or framework in the K-self-test or to write tests for drivers. And then also the other thing is hardware issue. So having hardware available to test some of the drivers. So I think we do have a lot of areas. I don't think we actually have to go looking for them. Coverage wise, we don't cover a lot of the drivers right now.
Well, could we make that a call to arms? But like, with aggregating data, I know a lot of CI services have their they have their set of hardware. But we call out to the communities like, hey, we're looking for this type of hardware. Could we have them run tests and contribute data back? Maybe it's not trusted data, but it could be something just to show that we're getting some coverage. Would that be helpful?
Yeah, I mean, definitely. If we can get more data from people that are running tests on hardware.
So would it be worth putting some sort of stats on a web page saying, hey, here's the hardware we're covering. Here's the hardware we would like to see coverage from, but we're missing. Would that be? I'm just throwing out ideas here. Capture the spirit of what you're looking for.
Right. And I mean, when I did it recently, I did go look at the different rings and how they accept new tests and new hardware. Looks like most of the test rings, Kernel CI, LKFD, and 0-day, they all accept suggestions for new tests being added to their test rings. Somebody has to go make a request and add them. Like, for example, there was a comment about stress-ng. If you want to add stress-ng to an existing test string, somebody has to go and say, hey, please add this, right? Go through their channels for adding tests. And same thing with hardware. You have to go request and say, you could also request adding hardware and also provide hardware to be added. So those are the two components. Seems like all of the existing, so I think I'm answering your question in a roundabout way. Looks like our test strings, existing test strings, do have provisions for people to go add hardware and tests for them. So that's another way. Request, and then if you know a particular test that you think that covers a certain area that's not covered right now, we request that and then get data from that way. So,
and I think, Don, in the spirit of you're trying to do exactly what I was trying to do with the project I spoke about earlier, is it's like if 5 seconds you look at the main kernelci.org page and you instantly know how we're doing, right? The question is like, well, is that showing how we're doing on ARM or MIPS or PowerPC or, those things? Like, do people need that level of detail? Or is it, because I think what we mostly want, right, is like, how's the kernel doing, overall, right? How are the file system, subsystems and those kind of things doing? And then some of us care about specific hardware, and then maybe that's like a click through where you get to that. But just overall, like it just would be fantastic to have that 5 second, like, you know exactly what's going on, and then everything else after that's drilled down. And that's the approach I was taking. But again, the big data, this is actually the problem, and that's I just want everybody to understand. If we don't get data scientists involved for the big data, we're going to continue to not get to where we really, really want to be.
Sure, I like those ideas. I'm just, I like the idea of the click through, and that all makes sense. It's really the 5 second view. Really, what do we put up there to kind of show what does it mean that the Linux is stable? I guess it does mean stable for a lot of different reasons, but if we kind of come up with an idea, like I use Linux stable a lot because it's that's something a lot of people use, and they want that to be, they want to use that for the company, and they want to just to work. And what does that mean? And what are some of the issues they have there?
I would say the kernel code coverage is really the first metric. It's very basic. It misses lots of things, but while we have lots of code with zero coverage, I would say it's less important how well, like, few lines we cover are covered.
When you say
Yeah,
kernel coverage, are you talking GCov, KCov?
Line coverage, any kind of line coverage we can get.
The CKI runs GCov now on LTP and a lot of our tests, and we can look to promote that data if that helps. Thanks, Dimitri.
That seems to be more useful than just the idea of bug count, because as we saw in Dimitri's slides, the bug count is not really a good indicator, because we know, because of the low coverage, we know that our bug count is probably going to keep going up faster than we can deal with it, right? So hopefully not forever, but
the other thing I think on, or another thing I think on coverage is we should probably be doing something to try and differentiate between coverage of subsystems and cores frameworks and coverage of Leaf device drivers. There's a lot of Leaf device drivers that may be quite large, but approximately no people have access to. So even among users of the subsystem, so it's not super critical if they have weak coverage. Whereas if we've got a subsystem core that's not being exercised very well, then that's got a much bigger impact and needs much more focus.
Okay, I'm happy to try to generate, code coverage data like in GCov and start putting some drill down stats on the web page just to start to show what our hardware coverage and hardware, I guess, exercisability is. Is that sort of what you're suggesting, Mark?
No, so more the other thing, like we've a couple of people have been talking about code coverage, and I'm saying when we're looking at code coverage, we probably want to differentiate between coverage of drivers and coverage of hardware, because not all the hardware specific stuff, because not all the hardware specific stuff is equal in terms of importance and value to people.
Okay. So this is going to kind of be like one of those work in progress type of things. So it seems like hardware coverage and maybe some software coverage are some good starts. I can try to throw out some stats up there, some drill down stats, as Tim alluded to, on the web page, just to kick things off, and just as people, as I start promoting, people can just provide feedback saying, yeah, it's not quite there. Let's keep tweaking until it becomes more valuable. Of course, on the flip side, it requires us to focus on getting that data inside the database.
So I played around with GCov a little bit, and one of the issues I ran into is you have a bunch of different test suites. You get coverage reports for each test suite and different, like each kernel configuration, but there isn't really a good way to combine that coverage data and have a single view of all of your coverage.
We found Red Hat has a way. Our QE team, I believe, Rachel's on the chat. She could probably throw it in there. I think we have a way to.
That would be awesome.
I haven't played with it too much. I'm going to rely on her to kind of talk more about it, and maybe Nikolai has some familiarity with that. But I think I think we can share it. If that's the case, I'll make sure Are you on the automated testing mailing list, Brendan?
Yes.
We can if we can share it, I'll share it there. I think it seems like an appropriate place to share it.
Cool. Appreciate it.
No problem.
So there's one other comment in the chat about measuring the time it takes to fix a bug, and I think, Dimitri, you guys are doing this already with the syscaller data, right? How long it takes from when you report a bug to when it actually lands in mainline and stable? That
yes.
seems to be an interesting metric that could be that would be good to chart to see if the average time from finding something to fixing it is actually kind of where that's trending.
Yeah, maybe you want to see a histogram, because like single average number may not be representative.
Right. Yeah.
It would happy to. I mean, that's syscallers providing that data. I guess we could find some stats. I always got the impression that a lot of bugs by CI services are found as people are posting patches, so that either the patches are rejected early on, or is a lot of the bugs we're finding after they're committed. Dimitri's obviously finding them after we committed, but for kernelci.org and CKI and 0 Day, are we finding them before they're committed?
Yeah,
But
we're
I mean,
finding
what would
stuff
you-
sometimes that lands in mainline or in stable tree that was missed. So yeah, we find in all directions. Yeah.
I mean, what would you do with the histogram of how long it takes to fix a bug? I mean, you can't yell at people to fix stuff faster, you know.
No, but I think it would be interesting to see what that trend is. If it's taking us longer and longer to fix bugs, that would be an indicator of, you know, of lack of resources in the kernel community or the testing community or something. If we're getting better, I think what Don is trying to get at is just how do we measure that the testing efforts on the kernel are actually worth continuing to spend time on, right? We all have the sense that that it's providing value, but we don't have a good way to measure, or we don't know exactly what the right things to measure are.
Yeah, I mean, I think that the trend will show that it takes longer to fix bugs just because there's more of them.
Yeah.
Some bugs, you know, it's not like we're getting more people day by day, you know. We're getting more bugs thanks to like Dimitri's work, but we don't get more people to fix them.
But then that might result in an emphasis on tooling, right? Maybe we need better tooling so that humans aren't the bottleneck.
Kind of going back to, I think it was in chat, Dimitri made a comment about doing a directory breakdown. It might be kind of cool to see, like, looking on a per directory basis, what the biggest offenders in bug fix latency. Like, you could do a breakdown of average bug fix latency per directory or even per file. That could help you spot problem areas in the kernel.
Okay.
I guess an interesting thing here is that there's sort of two separate things that you're measuring. Like, if you're looking at coverage, that's sort of almost the denominator of all of the things you're potentially testing. If you're trying to look at bug latency, it's almost the quality of that testing within an area. So as Brendan's suggesting, trying to work out how you can correlate that, you know, it's no sense expanding huge amounts of, you know, the coverage if the tests you've got are not actually being useful. And if you can look at, again, and then per directory, you know, where the useful tests are, that might be the best place to expand coverage.
Well said, David. That also makes me think of measuring incremental coverage as opposed to just absolute coverage.
From measuring from what, release to release, or just from kernel?
Change to change. Basically, you care more about measuring the coverage for new code added into the kernel rather than code that's been there for a long time and hasn't changed.
Oh, I see. Oh, interesting. That's an interesting twist. Okay. So again, I'm starting to see that source code coverage is trending. I haven't looked at the chat yet, but that seems to be popular. Hardware, showing hardware coverage is popular. We can do latency bug fixes. That's probably pretty straightforward. I do realize someone brought up the config options. A lot of this stuff is going to be dependent on what config options you use. That adds complexity to the matrix, but I'm willing to start somewhere.
I think we would also need to figure out where the users are, or if there are subsystems that users care more about or care less about, because we might find the subsystem is full of bugs, but it has only 5 users in practice, and then it's not worth investing efforts there.
Is there a way to determine our top used hardware or hard subsystems that are most popular? I don't even know how to measure that.
I don't have a good idea around it.
It's a good point. I don't know how to filter that.
Imagine you get at least some correlation if you're measuring the architectures and drivers that get the most changes. Like, yeah, for things that have been around a long time that are heavily used, it won't be a strong indicator of that. But presumably, people, like things that people care about, are going to get more changes.
So the most active subsystems from the change perspective would be a good way to start measuring?
I think so.
And if things aren't getting much changes, even if they are widely used, then presumably they work well for everybody, and there's hopefully not that many problems there.
So I mean, look at Bluetooth. It's not changing much, but it's full of problems, as Dimitri pointed out.
Yeah, it's not a guarantee, but it's it's a rule of thumb. And it's not like we won't find anything to look at with simple metrics.
Another potential dimension is sanitizers. For example, would this code ever execute as KSN or KMSN at least once, or logdep? But if we do something more elaborate than just simple coverage, I think there will be like multiple views or slices of this data, because, for example, some people will only be interested in ARM and some people not interested in ARM at all. And so on, and the same hardware.
Yeah, we're going to have to tag the data a lot so you can slice it a different way to get the right views. Okay, I guess my time's up. Thank you for all the discussion. This is good. I'll read the chat later, catch up on some of that stuff, but I'll put together a proposal and I'll put on the automated test mailing list. I think that's an appropriate place to go. Or is there a better mailing list to do that?
No, I think that's a good spot.
And I'll work with Guillaume to try to throw something up onto the Kernel CI org webpage. Thanks, everybody.
Thanks, Don. So that ends our testing and fuzzing micro conference, but we can continue the conversation in the hallway chat on Rocket Chat. Please feel free to hang out there. That'll space is open the rest of the week as well, and probably even longer. I'm not sure how long, but let's continue the conversations there. Anything else, Sasha?
Or if folks want to jump into the hack rooms and keep chatting, that works well too.
Yeah, there are hack rooms available if people want to keep if people want to do video chats as well.
You're welcome to stay here if you want. The only thing is people won't be able to join here if they leave.
Okay. Yeah, I'm willing to hang out. I'll hang out here for a little while if anybody wants to keep any particular conversations going. But officially, our micro conference is over. So thanks everybody for coming. If you have feedback on how the micro conference went, or what you'd like to see, what you liked, what you didn't like, feel free to send that as well to myself and to Sasha, or any of the LPC organizing committee if you want to say nasty stuff about us. Otherwise, thanks everybody for attending and participating. Experimental this year, but I think it worked as well as it could have worked. So yeah, appreciate everybody's participation, and thanks especially for all the speakers that organized topics and got some conversation started.
Yeah, thanks, Kay.
Thank you, Sasha. Thank you, Kevin. I will just hand it over there.